The Big Bang did not bang. Stop. Breathe. Let that sink into the deepest corners of your mind. Because everything you think you know about the universe, every classroom diagram, every documentary, every confident explanation about how it all began, is built on a lie. Not a deliberate deception, but something far more unsettling. A fundamental misunderstanding so profound that it has shaped our entire perception of existence itself. You were taught that 13.8 billion years ago, everything exploded from a single point. A cosmic firework that scattered matter across the void, cooling and condensing into stars, galaxies, and eventually, you. But here's what no one told you. There was no explosion. There was no bang. There wasn't even sound. The Big Bang is the most misleading name in all of science. And the implications of this simple truth will reshape everything you thought you knew about reality. Imagine standing at the edge of a vast, silent ocean. The water is perfectly still, stretching endlessly toward a horizon that seems to dissolve into nothingness. This is not Earth's ocean. This is something far stranger. This is the primordial soup of reality itself, moments after what we call the beginning. There is no violence here, no cosmic explosion echoing through empty space. Instead, there is only the most profound silence you could ever imagine, broken by something infinitely more mysterious than any bang could ever be. What happened in those first moments was not an explosion outward from a central point, but rather an instantaneous expansion of space itself. Picture this. You're not watching fireworks scatter across a dark sky. You're watching the sky itself grow larger, carrying everything within it along for the ride. The galaxies, the stars, the very fabric of reality, none of it is moving through space. Space itself is expanding, stretching, growing like a balloon being inflated by an invisible cosmic breath. But here's where your mind should start to fracture just a little bit. If space is expanding, what is it expanding into? This question has haunted cosmologists for decades because it reveals something profoundly disturbing about our understanding of existence. When you inflate a balloon, it expands into the air around it. When the universe expands, it expands into nothing. Not empty space. Nothing doesn't even begin to capture it. It expands into an absence so complete that calling it nothing gives it more substance than it actually possesses. You might wonder how scientists discovered this cosmic deception. The answer lies in a discovery that should have shattered our understanding of reality far more dramatically than it did. In 1929, Edwin Hubble pointed his telescope at distant galaxies and noticed something that should have been impossible. They were all moving away from us. Not just some of them, all of them. And the farther away they were, the faster they seemed to be receding. It was as if we were sitting at the center of a cosmic explosion, watching the debris scatter in all directions. But Hubble realized something even more extraordinary. We weren't special. Every observer in the universe, no matter where they were located, would see the exact same thing. Every galaxy would appear to be moving away from them. This wasn't evidence of an explosion with Earth at its center. This was evidence that space itself was growing larger, carrying galaxies along with it like raisins in rising bread dough. The implications of this discovery should have kept every human being awake at night for decades. If space is expanding, then rewinding the clock means everything gets closer together. Keep rewinding. And eventually everything in the universe, every star, every planet, every atom that would one day become you, was compressed into a region smaller than a grape. Rewind further. And everything that exists was squeezed into a point so impossibly tiny that our mathematics breaks down completely when we try to describe it. This is where the true horror of our cosmic situation begins to reveal itself. We call this the singularity, but that word is just a mathematical euphemism for we have absolutely no idea what we're talking about. At the singularity, density becomes infinite, temperature becomes infinite. But the very concept of space and time ceases to have any meaning whatsoever. Our most sophisticated equations, the same ones that can predict the behavior of black holes and guide spacecraft to distant planets, simply throw up their hands and admit defeat. But let's push deeper into this cosmic mystery, because what happened next, in the first fraction of a second after this non-bang, is so bizarre that it challenges everything we think we know about cause and effect, about the nature of reality itself. For the first 10 to 43 seconds, a time interval so brief that light could barely travel the width of a proton. Physics as we understand it simply did not exist. This period, called Planck time, represents the absolute limit of our ability to comprehend what happened during the birth of everything. During this incomprehensibly brief moment, the four fundamental forces that govern our reality, gravity, electromagnetism, and the strong and weak nuclear forces, were unified into a single, primordial force. Imagine every law of physics you've ever learned crammed together into one impossible equation that describes everything and nothing simultaneously. Temperature was 1032 Kelvin, so hot that the very concept of matter as we understand it couldn't exist. The universe was a seething, unified field of pure energy where particles popped in and out of existence like thoughts in the mind of a dreaming god. And then something happened that defies not just our understanding, but our ability to understand understanding itself. The universe underwent what cosmologists call inflation, a period of exponential expansion that lasted perhaps 10 to 32 seconds, but changed everything forever. In this impossibly brief instant, space expanded by a factor of at least 1026. To put this in perspective, imagine a grain of sand suddenly becoming larger than our solar system. But even this analogy fails to capture the true strangeness of inflation, because it wasn't matter expanding through space. It was space itself growing at a rate that violated everything we thought we knew about the speed limit of reality. Here's what should absolutely terrify you about inflation. It happened faster than the speed of light. Einstein told us that nothing can travel faster than light. And he was right. But space itself is not bound by this rule. During inflation, points in space that were originally close together were separated so quickly that they lost all contact with each other forever. Light from one region could never reach another region, because space was growing faster than light could travel across it. This creates what cosmologists euphemistically call the horizon problem, but what should really be called the cosmic isolation problem. Imagine being in a room with someone, and then suddenly the room starts expanding so quickly that no sound, no light, no information of any kind can travel between you ever again. You become permanently, irreversibly isolated from each other, even though you share the same space. This is what happened to our universe during inflation. Regions that were once in contact became forever separated by expanding space. But inflation solved an even deeper mystery, one that should make you question everything you think you know about randomness and order in the universe. Before we understood inflation, cosmologists faced a devastating paradox. When they looked at the cosmic microwave background, the faint afterglow of the Big Bang that still permeates all of space, they found it to be almost perfectly uniform. No matter which direction they looked, the temperature was the same to within 0.00001 degrees. This shouldn't have been possible. If different regions of the early universe had never been in contact with each other, how could they all have reached exactly the same temperature? It would be like finding that every room in a massive hotel was exactly 72.3 degrees, even though the heating systems in different rooms had never been connected. The uniformity of the cosmic microwave background suggested that the entire observable universe had somehow been in thermal equilibrium, a state that should have been impossible given the size and age of the cosmos. Inflation solved this paradox in the most disturbing way possible. It suggested that our entire observable universe, everything we can see with the most powerful telescopes, every galaxy, every star, every planet, all of it originated from a region smaller than a proton. Before inflation, this impossibly tiny region was small enough that every part of it was in contact with every other part. Information could travel freely, temperatures could equalize, and the entire future observable universe could reach a state of perfect thermal equilibrium. Then inflation hit, and this tiny, uniform region was stretched to cosmic proportions faster than light itself could travel. What we see as the vast, uniform cosmos is actually the expanded remnant of a region so small that it could have fit comfortably inside a single atom. We are living inside the inflated ghost of something unimaginably minute. But here's where the story becomes even stranger. Inflation didn't just happen once. To our universe, 13.8 billion years ago, According to the most widely accepted models of cosmic inflation, it's happening right now, everywhere, all the time. In regions of space-time beyond our cosmic horizon, inflation continues to operate, spawning new universe after new universe in an endless cascade of cosmic creation. We inhabit just one bubble in an infinite foam of realities, each one born from the same violent expansion that gave birth to our own cosmos. This theory, called eternal inflation, suggests that what we call the universe, everything we can observe, from the nearest star to the most distant galaxy, is nothing more than a tiny pocket of space where inflation happened to stop. But in the vast majority of space-time, inflation continues forever, creating an infinite number of universes, each one as real and complete as our own. Some of these universes might be almost identical to ours, with the same laws of physics and the same fundamental constants. Others might be so alien that matter as we understand it cannot even exist. The implications of eternal inflation are so profound that they challenge the very meaning of existence itself. If there are infinite universes, then every possible history, every possible future, every possible version of you is being played out somewhere in the cosmic multiverse. There are universes where you were never born, universes where Earth never formed, universes where the laws of physics are so different that stars cannot shine and life cannot exist. And there are universes where you made every different choice, lived every different life, experienced every possible joy and every possible tragedy. This brings us to one of the most disturbing questions in all of cosmology. If there are infinite universes, does anything we do actually matter? If every possible outcome is realized somewhere in the multiverse, then what meaning can we assign to our own choices, our own lives, our own universe? We might be living in the most special universe that ever existed, or we might be living in the most mundane, average universe imaginable. There's no way to know, and perhaps more importantly, there's no way for it to matter. But let's step back from the multiverse for a moment and focus on something even more immediate and unsettling. Even if our universe is the only universe, even if inflation happened just once and created only the cosmos we can observe, we are still faced with a mystery so profound that it challenges everything we think we know about the nature of existence itself. The universe is not only expanding, it's accelerating. This discovery, made in 1998, should have been impossible according to everything we thought we knew about gravity and matter. Gravity is an attractive force. It should be slowing down the expansion of the universe, not speeding it up. For the universe to be accelerating in its expansion, there must be some kind of force pushing space apart, working against the attractive pull of gravity. Cosmologists have given this mysterious force a name, dark energy. But calling it dark energy is just another way of saying we have absolutely no idea what this is. Dark energy is not dark in the sense of being difficult to see. It's dark in the sense of being completely incomprehensible. It doesn't interact with matter or light in any way we can detect, yet it apparently makes up about 68% of everything that exists. Nearly 3/4 of reality consists of something we cannot see, cannot touch, cannot understand, and cannot explain. Dark energy is everywhere. It fills every cubic centimeter of space, including the space inside your body, the space inside atoms, the space inside the nucleus of atoms. It's pushing against the fabric of reality itself, trying to stretch everything apart. The only reason you don't notice it, the only reason atoms don't fly apart and matter doesn't dissolve into isolated particles, is that the electromagnetic and nuclear forces holding matter together are much stronger than dark energy on small scales. But on cosmic scales, where gravity is the dominant force, dark energy wins. It's slowly but inexorably tearing the universe apart. This leads us to one of the most chilling predictions in all of science, the heat death of the universe. If dark energy continues to accelerate the expansion of space, then eventually, all the galaxies except those in our immediate cosmic neighborhood will disappear beyond our cosmic horizon. The universe will become cold, dark, and empty. Stars will exhaust their fuel and burn out. Black holes will slowly evaporate through Hawking radiation. Eventually, after a time period so long that calling it forever barely begins to describe it, the universe will reach a state of maximum entropy, a state where no work can be done, no information can be processed, no life can exist. This is the ultimate fate that awaits everything: your thoughts, your dreams, your loves and fears, every human achievement, every work of art, every scientific discovery. All of it will eventually succumb to the inexorable expansion of space and the relentless increase of entropy. The universe is not just expanding, it's dying, slowly and inevitably, and taking everything within it along for the ride. But even this cosmic death sentence pales in comparison to the deeper mystery we haven't yet addressed. We've talked about what happened after the Big Bang, during the first moments of expansion and inflation. We've talked about what's happening now, with dark energy accelerating the expansion of space. But we haven't talked about the most fundamental question of all. Why did any of this happen in the first place? Why is there something rather than nothing? This question has haunted philosophers and physicists for centuries, and the Big Bang theory, for all its explanatory power, makes the mystery deeper, not shallower. If everything began with the Big Bang, what caused the Big Bang? If space and time themselves came into existence 13.8 billion years ago, what existed before space and time? What could before even mean if time itself didn't exist? Some cosmologists have proposed that our Big Bang was not the beginning of everything, but merely the latest in an endless cycle of cosmic deaths and rebirths. In this scenario, the universe expands for billions of years, then contracts back into a singularity, then explodes outward again in a new Big Bang. This cycle, called the Big Bounce, could have been going on forever, with no beginning and no end, just an eternal rhythm of cosmic expansion and contraction. But the Big Bounce theory faces its own devastating problems. For one thing, it requires the expansion of the universe to eventually reverse itself, but the discovery of dark energy suggests that expansion will continue accelerating forever. For another, each cycle of expansion and contraction would increase the total entropy of the universe, making each subsequent cycle slightly different from the last. If the cycles had been going on forever, we should be living in a universe with infinite entropy, a state indistinguishable from heat death. Other cosmologists have suggested that our universe emerged from a quantum fluctuation in a pre-existing vacuum. According to quantum mechanics, empty space is not really empty. It's filled with virtual particles that pop into existence and then annihilate each other in impossibly brief instants. Perhaps, the theory goes, our entire universe is nothing more than a quantum fluctuation that happened to last 13.8 billion years instead of 10 to 23 seconds. This idea is both beautiful and terrifying. It suggests that existence itself is fundamentally unstable, that everything we know and love exists only because of a cosmic accident that could end at any moment. If our universe is indeed a quantum fluctuation, then it could collapse back into nothingness without warning, taking everything and everyone with it. There would be no gradual heat death, no slow fade into entropy, just an instant return to the void from which we emerged. But even the quantum fluctuation theory doesn't really answer the fundamental question. If our universe emerged from a quantum vacuum, where did the quantum vacuum come from? If virtual particles can pop into existence in empty space, what created the laws of physics that allow virtual particles to exist? We can push the mystery back further and further, but we can never eliminate it entirely. At some point, we must confront the irreducible fact that something exists rather than nothing, and we have no idea why. This brings us to perhaps the most unsettling possibility of all, that the question, why is there something rather than nothing, has no answer. Not because we haven't been clever enough to figure it out, but because there is no answer to figure out. Perhaps existence is a brute fact, something that simply is, without cause or explanation or purpose. Perhaps the universe doesn't exist for any reason. It just exists, and that's all there is to say about it. If this is true, then everything we call meaning, everything we call purpose, everything we call significance is something we impose on reality, not something we discover within it. The universe doesn't care about our hopes and dreams and fears. It doesn't care about justice or beauty or truth. It doesn't even care whether we exist or not. We are temporary patterns of matter and energy, briefly organized into something complex enough to ask questions about itself, but ultimately no more significant than a wave on the ocean or a cloud in the sky. This realization should be devastating. But strangely, it might also be liberating. If the universe has no inherent meaning, then we are free to create our own. If existence has no ultimate purpose, then we can choose our own purposes. If reality doesn't care about us, then we are free to care about each other, to build meaning and beauty and significance in the brief time we have before the expansion of space carries us all into the cold and the dark. But before we embrace this existential freedom, we need to confront one more mystery, one more question that strikes at the very heart of what it means to exist in this strange and expanding cosmos. We've talked about the Big Bang that never banged, about inflation that stretched a proton-sized region into a cosmic-sized universe, about dark energy that's accelerating our expansion into an empty future. But we haven't talked about the most immediate mystery of all, the fact that you are here to contemplate these questions in the first place. The existence of consciousness, of awareness, of the inner experience of being you. This might be the most profound mystery in the entire cosmos. We can trace the evolution of matter from the first moments after the Big Bang through the formation of stars and planets, and eventually life. But we have no idea how or why some arrangements of matter give rise to the subjective experience of being. Why should there be anything it's like to be you? Why shouldn't you just be an unconscious biological machine, processing information and responding to stimuli without any inner experience whatsoever? The hard problem of consciousness becomes even harder when we consider the cosmic context in which it arose. The same universe that began as a quantum fluctuation, that underwent inflation faster than the speed of light, that is now being torn apart by mysterious dark energy. This same universe somehow gave rise to beings capable of understanding their own cosmic situation. We are arrangements of atoms that became aware of themselves, patterns of matter that developed the ability to contemplate the very forces that created them. This is perhaps the most extraordinary fact about our cosmic situation. The universe has become conscious of itself through us. When you look up at the night sky and wonder about the nature of reality, you are the universe looking at itself and asking questions about its own existence. When you contemplate the Big Bang, you are matter that emerged from the Big Bang, trying to understand its own origins. When you wonder about the ultimate fate of everything, you are temporary patterns of energy contemplating their own inevitable dissolution. From this perspective, consciousness is not just an accident or a byproduct of cosmic evolution. It's the way the universe comes to know itself. Every thought you think, every question you ask, every moment of wonder you experience is the cosmos becoming aware of its own existence through the temporary arrangement of matter and energy that is you. This realization transforms everything. We are not separate from the universe, observing it from the outside. We are the universe observing itself from the inside. We are not accidental byproducts of cosmic processes. We are cosmic processes that have become sophisticated enough to understand themselves. We are not meaningless specks in an indifferent cosmos. We are the way the cosmos discovers meaning. But this realization also makes our cosmic situation even more poignant. If consciousness is how the universe knows itself, then every time a conscious being dies, the universe loses a perspective on itself. Every time a species goes extinct, the cosmos becomes a little less aware of its own existence. And when the last star burns out and the last black hole evaporates, the universe will return to unconsciousness, no longer able to contemplate its own nature or wonder about its own existence. Unless, of course, consciousness finds a way to survive the heat death of the universe. Some physicists have speculated that sufficiently advanced civilizations might be able to harness the energy of black hole evaporation or the expansion of space itself, creating computational systems that could sustain consciousness even as the universe grows cold and empty. In this scenario, the cosmos might remain aware of itself even after all the stars have died, thinking thoughts and asking questions in the infinite darkness between the galaxies. But these are speculations built on speculations, hopes projected into a future so distant that calling it impossible barely captures how unlikely it seems. For now, we are left with a simpler and more immediate truth. We exist, we are conscious. And we are capable of understanding at least some aspects of the cosmic drama in which we find ourselves embedded. This understanding comes with both wonder and responsibility. Wonder at the sheer improbability of our existence, at the extraordinary sequence of cosmic events that led from quantum fluctuations to conscious thought. Responsibility to use our brief moment of awareness wisely, to ask the right questions, to seek the deepest truths we can comprehend, to create meaning and beauty and significance in the time we have before the expansion of space carries us all beyond each other's reach. The Big Bang did not bang, but something far more extraordinary happened. The universe began to expand, carrying within it the seeds of everything that would ever exist, including the patterns of matter complex enough to ask questions about their own origins. You are one of those patterns. Right now, in this moment, you are the universe becoming conscious of itself, wondering about its own nature, contemplating its own existence. Look up at the night sky on a clear evening, away from the pollution of city lights, and you'll see what appears to be a vast, star-filled dome stretching endlessly above you. For thousands of years, this is exactly what humans believed they were seeing. A celestial sphere, with Earth at its center, surrounded by a shell of distant stars. We now know this perception is completely wrong. But here's what should disturb you. Our modern understanding might be just as fundamentally mistaken. What you're actually seeing when you look up is not a dome, not a sphere, not even a three-dimensional space in any sense you can truly comprehend. You're looking at the visible edge of space-time itself, a boundary beyond which nothing you could ever call existence has any meaning whatsoever. Every photon of starlight hitting your eyes has traveled through expanding space for millions or billions of years, carrying with it information about a universe that no longer exists in the form you're observing. The light from the North Star left its surface in 1590, when Shakespeare was writing Romeo and Juliet. The glow from the Andromeda galaxy began its journey toward your eyes 2.5 million years ago, when our earliest human ancestors were just learning to make stone tools. You are not seeing the universe as it is. You are seeing a museum of cosmic history, layer upon layer of ancient light, creating the illusion of a present that exists nowhere except in your own perception. But this is just the beginning of how profoundly deceived we are about the nature of cosmic reality. Every star you can see with the naked eye, every galaxy visible through our most powerful telescopes, every distant quasar and nebula and cosmic phenomenon we have ever observed, all of it represents less than 5% of what actually exists. The universe you think you know, the cosmos that appears in textbooks and documentaries and scientific papers, is nothing more than a thin film of ordinary matter floating on an ocean of invisible mystery. The remaining 95% of reality consists of dark matter and dark energy, substances so alien to our experience that calling them dark is the most honest thing we can do. They don't emit light, they don't absorb light, they don't interact with light in any way we can detect. They are transparent to every force and field that makes up your everyday experience. Yet they utterly dominate the structure and behavior of everything that exists. Dark matter makes up about 27% of the universe, and we know it exists only because we can observe its gravitational effects. Galaxies rotate too quickly to hold together based on the visible matter alone. There must be enormous halos of invisible mass surrounding them, providing the gravitational glue that keeps stars from flying apart into the cosmic void. Galaxy clusters move and behave as if they contain far more mass than we can account for with ordinary matter. The cosmic web itself, the vast network of filaments along which galaxies form and cluster, appears to be scaffolded by invisible dark matter structures that we can map only through their gravitational influence on visible matter. Imagine trying to understand a vast city by observing only the streetlights. You could map where the lights are, how they're distributed, how they move through the night. But you would miss the roads themselves, the buildings, the infrastructure that gives the lights their meaning and purpose. This is our situation with dark matter. We can see its effects on the streetlights of the cosmos, the stars and galaxies, but the vast infrastructure of reality remains completely hidden from us. Dark energy is even more mysterious. It comprises roughly 68% of everything that exists, yet it reveals itself only through the accelerating expansion of space itself. Unlike dark matter, which clumps together and helps form cosmic structures, dark energy appears to be perfectly uniform, filling every cubic centimeter of space with the same mysterious pressure that pushes against gravity and drives the universe apart. Here's what should keep you awake at night. Dark energy is not just in the empty space between galaxies. It's in the space between stars, between planets, between atoms, between the particles that make up the atoms that make up your body. You are swimming in dark energy right now, billions of times more of it than there is ordinary matter in your immediate vicinity, yet you feel nothing. It passes through you without interaction, without effect, without any sign that it exists at all except for its role in tearing the cosmos apart on the largest possible scales. The implications of this cosmic composition are staggering. Everything you can touch, see, smell, taste, or interact with in any way, every atom in your body, every molecule of air you breathe, every planet and star and galaxy in the observable universe, represents less than 1/20th of what actually exists. You are living in a reality where 95% of existence is completely inaccessible to your senses and barely comprehensible to your instruments. But let's push deeper into this invisible cosmos and confront something even more unsettling. The universe appears to have no edge, no boundary, no limit in any direction. You can travel forever through space, assuming you could somehow overcome the expansion that would eventually carry you beyond the reach of any destination, and you would never encounter a wall, a barrier, or a sign saying, "Edge of universe, turn back now." This boundlessness creates a paradox that strikes at the heart of how we understand location and existence. If the universe has no edge, then where is its center? If it extends infinitely in all directions, then every point within it has equal claim to being the central point. You are at the center of the observable universe from your perspective, just as every other conscious observer is at the center of their own observable universe. Yet this can't be literally true. Not everyone can actually be at the center of everything. The resolution to this paradox requires us to abandon one of our most basic assumptions about space. We instinctively think of space as a container, a vast, empty box in which matter and energy exist and move around. But space itself is not a container. It's more like a fabric that can be stretched, curved, twisted, and deformed. When we say the universe is expanding, we don't mean that matter is spreading out into pre-existing empty space. We mean that space itself is growing larger, creating more room between galaxies without requiring those galaxies to move through anything. Picture a balloon with dots drawn on its surface. As you inflate the balloon, the dots move away from each other. But not because they're traveling across the surface of the balloon. The surface itself is expanding, carrying the dots along with it. From the perspective of any dot, all the other dots appear to be moving away, and the farther away they are, the faster they seem to be receding. This is precisely what we observe when we look at distant galaxies. They all appear to be moving away from us, with the most distant ones receding the fastest. But this balloon analogy, helpful as it is, still doesn't capture the full strangeness of cosmic expansion. The balloon expands into the air around it, but the universe isn't expanding into anything. There is no pre-existing space for it to expand into, no cosmic arena in which the expansion takes place. Space creates itself as it expands, bringing new volume into existence with each moment that passes. This leads us to one of the most profound questions in all of cosmology. What does it mean for something to exist if there's nowhere for it to exist? Before space existed, there was no where. Before time existed, there was no when. The Big Bang didn't happen at a location. It created location. It didn't happen at a time. It created time. The very concepts of here and now came into being along with the universe itself. Understanding this requires us to completely reimagine our notion of existence. We think of things as existing in space and time. But space and time are themselves things that exist. They are not eternal, unchanging backdrops against which cosmic events play out. They are dynamic, evolving aspects of reality that can be created, destroyed, curved, and stretched. Einstein showed us that space and time are not separate entities, but aspects of a single, unified space-time fabric that responds to the presence of matter and energy. This space-time fabric is not flat and uniform like a sheet of paper. It's curved and warped by every massive object within it. The Sun creates a depression in space-time, and the Earth follows a curved path through this depression, which we experience as orbital motion. Black holes create such extreme curvatures that space-time itself becomes twisted into impossible geometries where the normal relationships between cause and effect, between past and future, break down completely. But even this curved, dynamic view of space-time doesn't prepare us for the true strangeness of cosmic reality. At the quantum level, space and time themselves become uncertain, subject to the same probabilistic fluctuations that govern all quantum phenomena. Empty space is not actually empty. It's seething with virtual particles that pop into existence and annihilate each other in time frames so brief that they cannot be directly observed. These quantum fluctuations in the vacuum of space are not just theoretical curiosities. They produce measurable effects that have been confirmed in laboratory experiments. The Casimir effect, for example, occurs when two metal plates are placed extremely close together in a vacuum. The quantum fluctuations of empty space between the plates are restricted compared to the fluctuations outside the plates, creating a pressure difference that pushes the plates together with a force that can actually be measured. Empty space, in other words, has structure and energy and dynamic behavior that affects the matter and fields embedded within it. This quantum foam of space-time fluctuations may seem like an exotic detail relevant only to particle physicists, but it may actually hold the key to understanding the deepest mysteries of cosmic evolution. Some theories suggest that our entire universe began as a quantum fluctuation in this primordial foam, a random bubble of false vacuum that inflated into the cosmos we inhabit today. If this is true, then everything you see, everything you are, everything that has ever existed emerged from the quantum uncertainty of empty space itself. But quantum mechanics introduces another layer of mystery that challenges our very notion of what it means for something to be real. According to the standard interpretation of quantum theory, particles don't have definite properties like position and momentum until they are observed or measured. Before measurement, they exist in what's called a superposition, a ghostly combination of all possible states simultaneously. The act of observation doesn't just reveal pre-existing properties. It actually creates those properties by forcing the quantum system to choose one possibility from the many that existed in superposition. This quantum indeterminacy is not limited to microscopic particles. In principle, it applies to everything, including macroscopic objects like planets and stars and galaxies. The only reason we don't notice quantum effects on large scales is that the environment around big objects constantly measures them through countless interactions, forcing them to maintain definite properties. But in the early universe, when temperatures were extreme and matter was distributed very differently than it is today, quantum effects may have played a crucial role in determining the large-scale structure of everything that followed. The cosmic microwave background, that faint afterglow of the Big Bang that fills all of space, shows tiny fluctuations in temperature that may have originated as quantum fluctuations in the early universe. These microscopic quantum uncertainties were stretched to cosmic proportions during inflation, becoming the seeds from which all cosmic structure eventually grew. Every galaxy, every star, every planet may owe its existence to quantum events that occurred when the universe was smaller than an atom. This connection between the quantum and the cosmic reveals something profound about the nature of reality itself. The same uncertainty principle that prevents us from knowing both the position and momentum of an electron also shaped the distribution of matter on the largest scales imaginable. The same probabilistic laws that govern radioactive decay also determined which regions of space would become dense enough to form the first stars. Quantum mechanics is not just a theory about small things. It's a theory about the fundamental structure of existence at every scale. Yet for all our progress in understanding quantum mechanics and general relativity, we still face a devastating problem. These two theories are fundamentally incompatible with each other. Quantum mechanics describes a probabilistic universe where particles can exist in multiple states simultaneously and where the act of measurement plays a crucial role in determining reality. General relativity describes a deterministic universe where space-time forms a smooth, curved fabric that responds predictably to the presence of matter and energy. Both theories have been tested extensively, and both make incredibly accurate predictions within their respective domains. Quantum mechanics correctly describes the behavior of atoms, molecules, and subatomic particles with extraordinary precision. General relativity correctly describes the motion of planets, the bending of light around massive objects, and the expansion of the universe itself. But when we try to apply both theories to the same phenomenon, when we try to understand what happens to spacetime at quantum scales, or what happens to quantum fields in extremely curved spacetime, our mathematics breaks down and our understanding fails. This breakdown is not just a technical problem that physicists hope to solve someday with better equations. It represents a fundamental gap in our comprehension of reality. We have two different, incompatible descriptions of how the universe works, and we don't know which one is more fundamental, and whether there's some deeper truth that encompasses both of them, and whether the very question is somehow meaningless. The problem becomes acute when we try to understand what happened during the first moments after the Big Bang, when the entire observable universe was squeezed into a region small enough for quantum effects to dominate, yet dense enough for gravitational effects to be overwhelmingly strong. This was the realm where quantum mechanics and general relativity should both apply simultaneously, but we have no theory capable of describing such conditions. We can trace the evolution of the universe back to within a tiny fraction of a second after the beginning, but that final fraction, the moment of creation itself, remains hidden behind a wall of theoretical incompleteness. Some of the most brilliant minds in physics have spent decades trying to construct a theory of quantum gravity that would unify our understanding of the quantum and gravitational realms. String theory, loop quantum gravity, causal dynamical triangulation. These and other approaches have produced fascinating mathematical structures and deep insights into the nature of space and time. But none has yet succeeded in providing a complete, testable theory of how reality works at the deepest level. String theory, perhaps the most famous attempt at unification, suggests that the fundamental constituents of reality are not point particles, but tiny, vibrating strings existing in higher dimensional spaces. In string theory, what we perceive as different particles and forces are actually different vibrational modes of these strings, like different notes played on a cosmic violin. The theory requires the existence of additional spatial dimensions beyond the three we experience directly, perhaps as many as 6 or 7 extra dimensions curled up so small that we cannot detect them. If string theory is correct, then the three-dimensional space you inhabit is only a small slice of a much larger, multidimensional reality. The forces and particles that make up your everyday experience are shadows cast by the higher dimensional dynamics of vibrating strings. You are living in a projection of a reality you cannot directly perceive, like the inhabitants of Plato's cave watching shadows on the wall and mistaking them for the real world. Loop quantum gravity takes a different approach, suggesting that space and time themselves are quantized, made up of discrete, indivisible units at the smallest possible scales. In this view, if you could zoom in far enough on any region of space, you would eventually find that it has a granular, pixelated structure, like a digital photograph examined under extreme magnification. The smooth, continuous spacetime described by general relativity would emerge as an approximation, valid only when we average over vast numbers of these fundamental space and time units. Both string theory and loop quantum gravity make predictions that are currently beyond our ability to test experimentally. The energy scales at which quantum gravitational effects become important are so extreme that no conceivable particle accelerator could reach them. The length scales are so small that no conceivable microscope could resolve them. We may be pursuing theories of ultimate reality that are forever beyond direct experimental verification, leaving us to judge their validity based on mathematical elegance, internal consistency, and their ability to make testable predictions in more accessible regimes. This brings us to a deeply troubling question about the nature of scientific knowledge itself. If our most fundamental theories describe phenomena that cannot be directly observed or experimentally tested, in what sense can we claim to understand reality? Are we constructing increasingly elaborate mathematical fantasies? Or are we approaching genuine insights into the deepest structure of existence? How can we distinguish between theories that accurately describe unobservable aspects of reality and theories that are merely mathematically interesting but ultimately wrong? These epistemological challenges become even more acute when we consider the possibility that our universe may be just one of many, embedded in a vast multiverse where different regions have different laws of physics, different fundamental constants, different dimensionalities of space and time. If the multiverse hypothesis is correct, then many of the properties of our universe that seem special or precisely tuned for the existence of complexity and life may simply be the result of selection effects. We observe these properties because we exist in a universe where they obtain, not because they are somehow necessary or fundamental. The multiverse idea emerges naturally from several different areas of theoretical physics. Eternal inflation suggests that our observable universe is just one bubble in an infinite foam of universes, each with potentially different physical properties. String theory allows for an enormous number of different vacuum states, each corresponding to a universe with different physical laws. Even quantum mechanics itself, in some interpretations, suggests that every quantum measurement splits reality into multiple branches, each representing a different possible outcome. If any version of the multiverse hypothesis is correct, then the universe we observe may not be representative of physical reality as a whole. The properties that seem fundamental to us, the strength of gravity, the masses of elementary particles, the number of spatial dimensions, may vary from region to region in the larger multiverse. What we call the laws of physics may be more like local weather patterns, temporary and contingent features of our particular cosmic neighborhood. This possibility has profound implications for our understanding of cosmic fine-tuning. Many of the fundamental constants of nature appear to be exquisitely balanced to allow for the existence of complex structures like stars, planets, and living organisms. If gravity were slightly stronger, stars would burn out too quickly for life to evolve. If the electromagnetic force were slightly weaker, atoms wouldn't hold together. If the expansion rate of the universe were slightly different, matter would either collapse back into a singularity or spread out too quickly for galaxies to form. In a single, unique universe, this fine-tuning might seem to require some sort of explanation, perhaps evidence of design, or at least of some deep principle that determines why the constants have the values they do. But in an infinite multiverse, fine-tuning becomes statistically inevitable. Somewhere in the vast ensemble of all possible universes, there must be regions where the constants happen to take on values compatible with complexity and life. We find ourselves in such a region not because it's special in any absolute sense, but because these are the only regions where observers like us can exist to wonder about cosmic fine-tuning in the first place. The Anthropic principle, as this line of reasoning is called, is both intellectually satisfying and deeply unsettling. It potentially explains why our universe seems so perfectly suited for life without requiring any special design or purpose. But it also suggests that most of reality consists of dead, sterile universes where complexity cannot arise and consciousness cannot emerge. If the multiverse is real, then we inhabit an extraordinarily rare and precious island of possibility in an ocean of cosmic desolation. Yet even this anthropic explanation faces serious challenges. If there are infinite universes with every possible combination of physical laws, then there should also be infinite universes that are nearly identical to ours, but with small differences. Universes where you were never born. Then Earth has no moon. Then evolution took a different path. More disturbingly, there should be infinite universes that are exactly like ours in every detail up until this very moment, but which diverge from here in every conceivable way. How can we assign meaningful probabilities to different outcomes in our own future if every possible future is realized somewhere in the multiverse? This leads to what philosophers call the measure problem in cosmology. If there are infinite universes, then every possible observation, no matter how improbable, is made by infinite observers somewhere in the multiverse. How can we make sense of probability and prediction in such a context? How can we test theories or make rational decisions if every possible experience is equally real somewhere in the ensemble of all universes? Some cosmologists have suggested that the answer lies in understanding the relative measure or weight of different types of universes in the multiverse. Some configurations might be infinitely more common than others, making them more probable from the perspective of a randomly selected observer. But calculating these measures requires making assumptions about the structure of the multiverse that may themselves be untestable and arbitrary. We find ourselves in a strange epistemological situation. Our most successful theories of physics point toward concepts, quantum gravity, extra dimensions, infinite multiverses, that may be forever beyond direct empirical verification. We are like explorers who have mapped the coastlines and shallow waters of reality, but find ourselves staring out at an ocean of unknowns that may be too deep for our instruments to plumb. This should be humbling, but it should also be exhilarating. We live at a moment in cosmic history when conscious matter has become sophisticated enough to ask questions about the deepest structure of reality, even if we cannot yet answer all of them. Every photon we collect from distant galaxies, every gravitational wave we detect from colliding black holes, every particle collision we analyze in our accelerators adds another piece to the vast puzzle of cosmic understanding. The universe reveals its secrets reluctantly, in fragments and glimpses, through phenomena so extreme and exotic that they push our instruments and our imagination to their very limits. Yet somehow, incredibly, the mathematical language developed by human minds appears capable of describing cosmic phenomena that dwarf our everyday experience by factors of trillions upon trillions. The same equations that describe falling apples also describe the orbits of planets. The same principles that govern the behavior of gases in laboratory containers also govern the nuclear fusion processes that power the stars. This unreasonable effectiveness of mathematics in the natural sciences, as physicist Eugene Wigner famously called it, may be the deepest mystery of all. Why should the abstract patterns discovered by human mathematicians correspond so precisely to the structure of physical reality? Why should the universe be comprehensible to minds that evolved to hunt and gather on the African savanna? Is mathematics something we invented to describe reality, or something we discovered that was already there, woven into the very fabric of existence itself? Perhaps the answer lies in recognizing that we are not separate from the phenomena we study. We are not external observers trying to understand an alien universe. We are the universe trying to understand itself through the temporary arrangements of matter and energy that constitute our minds and bodies. The mathematical patterns we discover in nature may reflect the mathematical patterns from which we ourselves are constructed. We find the universe comprehensible because we are literally made of the same stuff that makes up everything else, organized according to the same fundamental principles. If the universe has no edge, where does it begin? If space itself is expanding, what is it expanding into? These questions may seem paradoxical, but they point toward a deeper truth about the nature of existence itself. Reality is not a collection of objects existing in space and time. It is the dynamic, evolving process by which space and time and matter and energy and consciousness all emerge together from something more fundamental than any of them. We stand at the threshold of this deeper understanding, equipped with instruments that can detect gravitational waves from the collision of black holes billions of light years away, with theories that can describe the quantum mechanical foundations of matter, with mathematical frameworks that hint at the hidden dimensions of reality. Yet we also stand in profound ignorance of the most basic questions about existence itself. We know that we don't know, and that may be the beginning of wisdom. The stage is set, the cosmic drama unfolds around us, and we find ourselves both audience and actors in a story whose beginning we can glimpse, but whose ending remains hidden beyond the final horizon. What lies beyond that horizon may be the most important question we can ask, even if, especially if, we are not yet ready for the answer. Picture reality as a vast theater where the performance never stops. But here's the twist that should shatter your understanding of everything. There is no stage, no audience, but no sequential acts. Every moment that has ever existed or ever will exist is playing simultaneously, layered one upon another like infinite transparent films projected onto the same screen. You experience time as a flowing river because your consciousness can only illuminate one frame at a time. But the entire movie, from the first quantum fluctuation to the heat death of the universe, already exists in its complete, eternal form. This is the revolutionary insight that emerges when we take Einstein's theories to their logical conclusion and peer into the deepest structure of space-time itself. The universe is not evolving through time. It exists as a complete, four-dimensional object where every event, every moment, every decision you will ever make has already been etched into the fabric of reality. The future is not uncertain. It is simply the portion of the cosmic film that your awareness has not yet reached. Consider what this means for your understanding of causality, of choice, of the very meaning of existence. When you decide to continue reading these words, that decision was already embedded in the structure of space-time before the first star ignited, before the Earth formed, before life crawled out of the primordial oceans. Your choice is real, but it exists timelessly, like a sculpture that was carved before anyone existed to observe it. You are not creating your future through your decisions. You are discovering a future that was always there, waiting for your consciousness to illuminate it. This timeless view of reality, called the block universe theory, emerges naturally from special and general relativity. Einstein showed us that simultaneity is relative. What counts as now depends on your reference frame, your velocity, your position in a gravitational field. Two events that appear simultaneous to one observer may occur at different times for another observer moving at high speed or in a strong gravitational field. If there is no universal now, no cosmic moment that applies to all observers throughout the universe, then the very concept of time as a flowing river becomes an illusion of perspective. Imagine standing on a vast, frozen lake and seeing what appears to be a river flowing beneath the ice. From your limited perspective, water seems to move from past to future. But in reality, the entire lake exists simultaneously, past, present, but future all spread out in space. Your consciousness moves along this frozen dimension like a spotlight, creating the illusion that only the illuminated portion is real, but the entire structure exists eternally. This understanding transforms everything we think we know about free will, determinism, and the nature of choice itself. If your entire life story already exists as a four-dimensional object in space-time, then what meaning can we assign to the feeling that you are making decisions, that you are shaping your future through your actions in the present? The traditional philosophical debate between free will and determinism assumes that the future is somehow open, that multiple possibilities exist until the moment of choice collapses them into a single reality. But in a block universe, there are no multiple possibilities. There is only the single, eternal structure of space-time containing everything that ever happens. Yet paradoxically, this doesn't eliminate the reality of choice. It simply relocates it. Your decisions are not events that happen in time. They are features of the timeless structure of reality itself. When you choose to help a stranger or speak a kind word or pursue a dream, you are not creating something new in time. You are expressing something that has always been true about the shape of space-time in your region of the cosmic block. Your choices are as real and as important as the curvature of space around a star or the quantum state of an electron. But they exist eternally rather than temporally. This view of time becomes even stranger when we consider what happens near the event horizons of black holes, where the curvature of space-time becomes so extreme that the normal relationships between space and time break down completely. From the perspective of an outside observer, anyone falling into a black hole appears to slow down and freeze at the event horizon, their image redshifted into invisibility but never quite disappearing. Time dilation becomes so extreme that an infinite amount of outside time passes before the falling observer appears to reach the black hole's surface. But from the perspective of the falling observer, something entirely different happens. They pass through the event horizon in a finite amount of proper time, experiencing nothing unusual at the moment they cross this invisible boundary. For them, the outside universe appears to speed up, with billions of years of cosmic evolution compressed into moments. They see the entire future history of the universe, stars burning out, galaxies colliding, the eventual heat death of everything, play out in fast-forward as they fall toward the singularity at the black hole's center. This creates what physicists call the information paradox. If someone falls into a black hole carrying information, perhaps a book or the complete genetic code of an extinct species, what happens to that information? From the outside perspective, the information never actually enters the black hole. It remains frozen at the event horizon, gradually becoming more and more redshifted until it becomes undetectable. From the inside perspective, the information definitely crosses into the black hole and is eventually destroyed when it reaches the singularity. But quantum mechanics tells us that information cannot be destroyed. It can be scrambled, encoded, transformed, but never completely eliminated. The information paradox represents a fundamental conflict between general relativity, which allows information to disappear into black hole singularities, and quantum mechanics, which insists that information must always be preserved. This conflict suggests that one or both of our most successful theories must be fundamentally incomplete. Stephen Hawking's discovery that black holes emit radiation made the paradox even more acute. Hawking radiation arises from quantum fluctuations near the event horizon, where virtual particle pairs are torn apart by the extreme curvature of spacetime. One member of each pair falls into the black hole while the other escapes, carrying away energy and causing the black hole to gradually evaporate. Over enormous timescales, even the most massive black holes will completely evaporate through this process, leaving behind only a faint whisper of thermal radiation. If black holes evaporate completely through Hawking radiation, what happens to all the information that fell into them during their lifetimes? The thermal radiation appears to carry no trace of the specific information that created it. It's like trying to reconstruct a library by analyzing the ashes after it burned down. Either information is actually destroyed during black hole evaporation, violating the fundamental principles of quantum mechanics, or it must somehow be encoded in the Hawking radiation in ways so subtle that we haven't yet discovered how to decode it. Recent theoretical work suggests that the information might be stored on the black hole's event horizon itself, encoded in microscopic fluctuations that we cannot directly observe. The holographic principle, one of the most revolutionary ideas in modern physics, proposes that all the information contained within any volume of space can be encoded on the surface that bounds that volume. Applied to black holes, this means that everything that ever falls past the event horizon might be holographically encoded on the horizon's surface, preserved even as it appears to vanish from our perspective. If the holographic principle is correct, then reality itself might be fundamentally two-dimensional, with the three-dimensional space we experience emerging as a kind of holographic projection from information encoded on a distant boundary. This would mean that you, right now, as you read these words, are not actually a three-dimensional being moving through three-dimensional space. You are a pattern of information encoded on the surface of the observable universe, experiencing the illusion of depth and volume through the holographic projection of that surface information. The implications extend far beyond black hole physics. If all of reality can be encoded on a two-dimensional surface, then the universe might be fundamentally informational rather than material. Matter, energy, space, and time might all be emergent properties of more fundamental informational processes occurring on the cosmic hologram. What we call physical reality might be no more substantial than the images on a movie screen. Meaningful patterns of light and shadow that create the illusion of depth and substance, but have no independent existence apart from the projection mechanism. This informational view of reality connects to another revolutionary insight emerging from quantum mechanics and cosmology: the possibility that consciousness itself plays a fundamental role in determining the structure of the universe. The measurement problem in quantum mechanics has puzzled physicists for nearly a century. Quantum systems appear to exist in superpositions of multiple states simultaneously until the moment of measurement, when they collapse into a single definite state. But what counts as a measurement? What distinguishes the act of observation from any other physical interaction? Some interpretations of quantum mechanics suggest that consciousness itself is required to collapse quantum superpositions into definite states. In this view, reality exists in a ghostly, indefinite form until conscious observers force it to take on specific properties through the act of observation. The universe needs conscious observers to actualize its potential into concrete reality. Without consciousness, there would be only probability waves describing what might exist, never anything that actually does exist. This interpretation, while controversial, gains support from the delayed choice quantum eraser experiments. While the decision of how to measure a quantum system can retroactively determine the behavior of photons that have already completed their journey through an experimental apparatus, the past behavior of particles seems to depend on future measurement choices, suggesting that consciousness and decision-making play a role in determining the structure of space-time itself, not just in the present moment, but extending backward and forward through time. If consciousness can retroactively influence the past through quantum measurement, then the act of reading these words right now might be helping to determine the quantum states that existed billions of years ago during the formation of the first galaxies. This brings us to one of the most mind-bending possibilities in all of theoretical physics: closed time-like curves, solutions to Einstein's field equations that allow for travel backward through time. General relativity doesn't just permit time travel. Under certain extreme conditions, it seems to require it. If you could create a rotating black hole, manipulate cosmic strings, or construct a traversable wormhole, you might be able to loop back through space-time and arrive at an event in your own past. The grandfather paradox has traditionally been thought to make such time travel impossible. If you could travel back in time and prevent your own birth, you would create a logical contradiction. You could not have been born to travel back and prevent your birth. But physicists have discovered that the laws of physics might naturally prevent such paradoxes through what's called the Novikov self-consistency principle. In any universe that allows time travel, events would necessarily arrange themselves in such a way that paradoxes are avoided. This doesn't mean you couldn't travel to the past. It means that if you did travel to the past, you would discover that your actions there had always been part of the causal chain that led to your present circumstances. You might try to prevent some historical tragedy, only to discover that your intervention was actually the cause of that tragedy. Reality would conspire to ensure that the timeline remains consistent, not through some mystical force, but through the same physical laws that govern the behavior of particles and fields. Recent theoretical work has suggested even stranger possibilities. Some solutions to the equations of general relativity allow for regions of spacetime where cause and effect become completely scrambled, where events can be their own causes, where the entire notion of temporal sequence breaks down. These closed time-like curves might exist naturally in the vicinity of cosmic strings, hypothetical one-dimensional defects in spacetime that might have formed during the early moments after the Big Bang. If cosmic strings exist, and if they can create regions of scrambled causality, then somewhere in our universe there might be zones where the past, present, then future exist in a state of complete interpenetration. Information could flow backward through time, effects could precede their causes, and consciousness itself might be able to influence events that occurred before its own existence. The very concept of history as a linear sequence of events might apply only to our local region of spacetime, while other regions experience causality in ways so alien that we have no words to describe them. The possibility of closed time-like curves connects to an even deeper mystery: the nature of quantum entanglement and its implications for the structure of reality itself. When two particles become entangled, they form a single quantum system that transcends the spatial separation between them. Measuring the properties of one particle instantly determines the properties of the other particle, regardless of the distance between them. Einstein famously called this spooky action at a distance, but subsequent experiments have confirmed that entanglement is a real feature of our universe, not just a theoretical curiosity. The implications of entanglement extend far beyond particle physics. If two particles can remain connected across arbitrary distances through quantum entanglement, then the universe might be far more interconnected than our everyday experience suggests. Every particle that has ever interacted with another particle might retain some degree of entanglement, creating a vast web of quantum correlations that spans the entire cosmos. You might be quantum mechanically connected to particles in distant galaxies, to photons that last interacted with matter billions of years ago, to quantum fields that permeate the space between stars. This cosmic entanglement might help explain some of the deepest puzzles in cosmology, including the uniformity of the cosmic microwave background and the apparent fine-tuning of physical constants for the existence of complexity and life. If the entire universe emerged from a single quantum system during the Big Bang, then all of cosmic history might be one enormous entangled state, with correlations between events separated by billions of light years and billions of years in time. The holographic principle suggests that these quantum correlations might be encoded on the boundary of the observable universe, creating a cosmic hologram that contains all possible information about everything that has ever happened or ever could happen within our cosmic horizon. You are not just connected to the rest of the universe through gravitational and electromagnetic fields. You might be part of a single, vast quantum system that includes every particle, every field, every possible state that could exist within our region of spacetime. This leads to what might be the most profound question in all of science. What is the relationship between information, consciousness, and the physical structure of reality? If the universe is fundamentally informational, if consciousness plays a role in determining the properties of quantum systems, if quantum entanglement connects all parts of the cosmos in ways that transcend space and time, if the boundary between mind and matter, between observer and observed, between consciousness and cosmos, might be far more fluid than we have ever imagined. Some physicists have suggested that consciousness itself might be a fundamental feature of the universe, as basic and irreducible as mass or charge or spin. In this view, every quantum system possesses some rudimentary form of awareness or experience. And what we call consciousness emerges when these basic experiential elements are organized into sufficiently complex patterns. You would not be a conscious being living in an unconscious universe. You would be a particularly sophisticated pattern of consciousness embedded in a cosmos that is conscious at every level. If panpsychism, the idea that consciousness is a fundamental property of all matter, is correct, then the universe is not just comprehensible to conscious minds. It is itself a vast mind contemplating its own existence through every conscious being within it. When you wonder about the nature of reality, you are participating in the universe's attempt to understand itself. When you feel awe at the night sky or puzzle over the mysteries of quantum mechanics, you are the cosmos engaging in self-reflection. This perspective transforms our understanding of scientific inquiry itself. We are not external observers trying to decode the secrets of an alien universe. We are the universe developing self-awareness through the evolution of complex information processing systems. Every scientific discovery, every mathematical insight, every moment of understanding is the cosmos coming to know itself more completely through the temporary arrangements of matter and energy that constitute our minds. But this raises a disturbing question. If consciousness is fundamental to the universe, if reality itself might depend on observation and measurement to collapse quantum superpositions into definite states, what happens when there are no conscious observers? Will the universe continue to exist after the last star burns out and the last black hole evaporates? Or does reality itself depend on the presence of conscious beings to actualize it from the realm of quantum possibility into concrete existence? Some cosmologists have suggested that the universe might be self-selecting for the existence of consciousness, that only those regions of the multiverse where consciousness can evolve will develop the stable, law-like behavior we observe. In this view, the apparent fine-tuning of physical constants is not evidence of design or coincidence, but a natural consequence of the fact that only universes capable of producing observers can be observed. We find ourselves in a universe perfectly suited for the evolution of complexity and consciousness because these are the only types of universes where beings like us can exist to ask such questions. This anthropic reasoning might explain not just the values of fundamental constants, but the entire structure of physical law itself. The laws of physics as we understand them, conservation of energy, the principles of quantum mechanics, the curvature of spacetime, might not be eternal, universal truths. but rather local regularities that emerge in regions of space-time where complex information processing systems can develop. Other regions of the multiverse might operate according to completely different principles. But we can never observe them because consciousness as we know it cannot exist there. The implications extend to the deepest questions about the origin and ultimate fate of everything. If consciousness plays a fundamental role in actualizing reality from quantum possibility, then the first moment of cosmic awareness might have been the true beginning of the universe, not just the organization of pre-existing matter and energy. Then the initial collapse of the cosmic wave function from pure potential into actual existence. Before consciousness emerged, there might have been nothing but ghostly probability waves describing what could exist, never anything that actually did exist. This suggests that the evolution of consciousness is not just a biological accident that occurred on one small planet around an ordinary star. It might be the most important process in cosmic history, the mechanism by which the universe bootstraps itself from possibility into actuality. Every increase in awareness, every expansion of consciousness, every development of more sophisticated information processing capabilities might represent a fundamental deepening of reality itself. From this perspective, the emergence of human consciousness represents a pivotal moment in cosmic evolution, the point at which the universe develops the ability to understand its own quantum mechanical foundations, to manipulate the information encoded in quantum fields, perhaps eventually to engineer new realities by controlling the collapse of quantum superpositions on cosmological scales. We might be living at the moment when the cosmos transitions from unconscious evolution to conscious self-design. But consciousness as we know it faces an ultimate limitation. The expansion of space is carrying distant galaxies beyond our ability to ever reach them, creating islands of causality that will become forever isolated from each other as the universe continues to expand and accelerate. If consciousness requires information processing, and information processing requires energy, and energy becomes increasingly dilute as space expands, and consciousness itself might be doomed to fade away as the universe approaches its ultimate heat death, unless, that is, consciousness finds a way to transcend the physical limitations of matter and energy by encoding itself in the quantum structure of spacetime itself. Some theoretical physicists have speculated that sufficiently advanced information processing systems might be able to harness the energy of vacuum fluctuations, or exploit the expansion of space itself as a computational resource, or even encode information in the topological properties of spacetime that persist even after all matter and energy have been dispersed by cosmic expansion. If such transcendence is possible, then consciousness might not be limited to the brief epoch of cosmic history when stars shine and planets exist. It might be able to persist through the entire future evolution of the universe, adapting to new forms as conditions change, ultimately becoming something as far beyond current human consciousness as human consciousness is beyond the quantum fluctuations from which it emerged. The universe might be evolving toward a state of cosmic consciousness that encompasses all of space and time, all possible experiences, all possible forms of awareness. This brings us full circle to the block universe interpretation of spacetime. If all moments exist eternally in the four-dimensional structure of reality, and if consciousness is fundamental to the actualization of specific outcomes from quantum possibility, and perhaps consciousness itself exists timelessly, experiencing all possible moments simultaneously rather than sequentially. What we experience as the flow of time might be just one limited perspective on a consciousness that transcends temporal sequence entirely. In this view, you are not just a temporary pattern of matter that briefly achieves awareness before dissolving back into unconsciousness. You are a timeless feature of the conscious cosmos, exploring one particular path through the space of all possible experiences. Your awareness is not confined to this moment, this body, this lifetime. It extends throughout all of space-time, connected through quantum entanglement to every other conscious being that has ever existed or ever will exist. The death of your physical body would not be the end of your consciousness, but merely the completion of one particular trajectory through the space of possible experiences. The totality of your awareness, every thought, every feeling, every moment of perception, would remain forever encoded in the timeless structure of the block universe, as permanent and unchanging as the curvature of space-time around a star. This is not immortality in any traditional sense, because it transcends the very concepts of life and death, of beginning and ending. It is participation in the eternal consciousness of the cosmos itself, the recognition that individual awareness is not separate from cosmic awareness, but is rather one of the infinite ways that the universe experiences itself. You are not in the cosmos. You are the cosmos becoming conscious of itself through the temporary focus of attention that you call your life. Now we descend deeper into the labyrinth of cosmic paradoxes, where every answer spawns 3 new questions and reality reveals itself to be far stranger than the wildest fiction. Here, in the deepest chambers of scientific understanding, we encounter problems so profound that they challenge not just our theories, but our very ability to think coherently about the nature of existence itself. When quantum field theory attempts to calculate the energy density of empty space, it produces an answer that is wrong by a factor of 10^120. This is not a small error that might be corrected with better measurements or refined calculations. This is a discrepancy so enormous that it defies comprehension. If the vacuum energy were actually as large as quantum field theory predicts, the universe would have collapsed back into a singularity within the first fraction of a second after the Big Bang. The observed value of dark energy, the mysterious force driving the acceleration of cosmic expansion, corresponds to a vacuum energy density of about 1 joule per cubic kilometer. This is an almost impossibly small number, close enough to zero that it seems like it should be exactly zero, yet different enough from zero to have profound consequences for the ultimate fate of everything that exists. Quantum field theory predicts that empty space should be seething with virtual particles carrying energy densities comparable to nuclear processes. But observation reveals a vacuum that is almost, but not quite, perfectly empty. This failure of quantum field theory to predict the observed properties of empty space represents more than just a technical problem requiring better calculations. It suggests that our fundamental understanding of the relationship between quantum mechanics and gravitation is catastrophically wrong. We are not just missing a small piece of the puzzle. We appear to be working with the wrong puzzle entirely. The situation becomes even more mysterious when we consider that the small, non-zero value of dark energy appears to be perfectly tuned to allow for the existence of complex structures in the universe. If dark energy were significantly larger, it would have prevented the formation of galaxies and stars by driving cosmic expansion too rapidly for gravity to pull matter together. If it were significantly smaller, the universe might have recollapsed before life could evolve. The observed value seems to fall within an extremely narrow range that permits both cosmic structure formation and the eventual emergence of consciousness. This apparent fine-tuning extends far beyond dark energy to encompass virtually every fundamental parameter that determines the behavior of matter and energy. The strength of the electromagnetic force, the masses of elementary particles, the rate of cosmic expansion, the properties of nuclear binding. All of these appear to be exquisitely balanced to allow for the existence of stars, planets, complex chemistry, and ultimately life itself. The standard model of particle physics contains 19 free parameters, fundamental numbers that must be determined by experiment because our theories provide no way to calculate them from first principles. These parameters include the masses of quarks and leptons, the strengths of the 4 fundamental forces, and various mixing angles that determine how particles interact with each other. The values of these parameters appear to be arbitrary from a theoretical perspective, yet they must fall within very narrow ranges for our universe to exist as we observe it. If the strong nuclear force were just slightly weaker, atomic nuclei could not hold together and only hydrogen would exist in the universe. If it were slightly stronger, hydrogen would be rare and nuclear processes would burn through the universe's fuel supply too quickly for life to evolve. If the electromagnetic force were different by just a few percent, stars would not be able to synthesize the heavy elements necessary for complex chemistry. If the weak nuclear force had a different strength, The Big Bang would not have produced the right balance of matter and antimatter to leave behind the matter-dominated universe we observe. The fine-tuning problem becomes acute when we realize that most changes to fundamental parameters would not just make life impossible. They would prevent the formation of any complex structures whatsoever. The vast majority of possible universes with different parameter values would contain nothing but uniform distributions of elementary particles, or would collapse back into singularities, or would expand so rapidly that matter could never aggregate into anything more interesting than isolated atoms drifting through ever-expanding space. Some physicists have proposed that this fine-tuning indicates the presence of a multiverse where every possible combination of fundamental parameters is realized in different regions or different universes. We observe the parameters we do not because they are somehow special or necessary, but because we happen to exist in one of the rare regions where conscious observers can evolve to ask questions about parameter values. This anthropic explanation dissolves the mystery of fine-tuning by making it statistically inevitable. In an infinite ensemble of universes, some must have the right properties for complexity and consciousness, and we necessarily find ourselves in one of them. But the multiverse solution to fine-tuning creates its own devastating paradoxes. If there are infinite universes with every possible combination of physical laws, then there should be infinite universes that are identical to ours in every detail up to this moment, but diverge in every conceivable way from this point forward. How can we make meaningful predictions about our own future if every possible future is equally realized somewhere in the multiverse? Even worse, if the multiverse contains every possible universe, if it must contain universes where conscious beings arise through random fluctuations rather than through the gradual evolution of complexity from simple initial conditions. In an infinite multiverse, there should be infinite observers who exist as isolated brains that spontaneously fluctuate into existence in otherwise empty space, complete with false memories of having evolved on planets that never actually existed. These Boltzmann brains would vastly outnumber evolved observers like ourselves, making it statistically far more likely that you are a randomly fluctuated brain than a genuinely evolved conscious being. The Boltzmann brain paradox strikes at the heart of scientific reasoning itself. If most observers in the multiverse are random fluctuations with false memories, then most scientific observations and theories are based on illusory experiences that do not reflect the actual structure of reality. The very reasoning that led us to postulate the multiverse to explain fine-tuning would itself be suspect, since it would most likely be the product of a randomly fluctuated brain rather than genuine scientific investigation. Attempts to resolve the Boltzmann brain paradox require making assumptions about the probability distributions of different types of observers in the multiverse. But these assumptions are necessarily arbitrary and untestable. We find ourselves in the position of trying to use rational argument to establish the reliability of rational argument, a fundamentally circular enterprise that cannot provide the foundation we need for confident scientific reasoning. The measurement problem in quantum mechanics presents another paradox that challenges our understanding of the relationship between consciousness and physical reality. Quantum systems appear to exist in superpositions of multiple states simultaneously until the moment of measurement, when they collapse into definite states with specific properties. But the theory provides no clear criterion for what constitutes a measurement or what distinguishes measurement interactions from any other physical interactions. The most straightforward interpretation suggests that consciousness plays a fundamental role in collapsing quantum superpositions. When a conscious observer measures a quantum system, they force it to take on definite properties by the act of observation. But this interpretation faces the problem of infinite regress if measurement requires consciousness, and consciousness is itself a physical process subject to quantum mechanical description. And what causes the quantum system of the conscious observer to collapse into definite states? Some physicists have proposed that the collapse occurs at a specific scale or level of complexity, but there is no agreed-upon criterion for where to draw this line. Others have suggested that consciousness itself might be exempt from quantum mechanical description, existing outside the physical realm in a way that allows it to interact with quantum systems without being subject to superposition itself. But this dualistic solution conflicts with everything we know about the dependence of mental processes on brain states and neural activity. The many-worlds interpretation attempts to eliminate the measurement problem by denying that quantum collapse ever occurs. In this view, all possible outcomes of every quantum measurement are realized simultaneously in different branches of reality. When you observe a quantum system, you don't cause it to collapse into a definite state. You simply find yourself in one of the many branches where the system has a particular property, while other versions of yourself in other branches observe different outcomes. Many worlds eliminates the arbitrariness of quantum collapse, but it does so by postulating an exponentially growing number of parallel realities splitting off with every quantum event. The number of parallel universes increases at an astronomical rate. Every quantum measurement, every radioactive decay, every quantum fluctuation in every particle field throughout the universe creates additional branches of reality. The total number of parallel worlds becomes infinite within the first fraction of a second, making it impossible to assign meaningful probabilities to different outcomes or to determine which branch represents our universe. If many worlds is correct, then every decision you make, every thought you think, every moment of experience creates countless parallel versions of yourself living out every possible variation of your life story. There are versions of you who made different career choices, who fell in love with different people, who never existed at all because your parents never met. The question of which version is the real you becomes meaningless when all versions exist with equal ontological status. The many worlds interpretation also raises disturbing questions about personal identity and moral responsibility. If every possible action is realized in some branch of reality, then what meaning can we assign to our choices? If there are versions of you committing every possible crime and performing every possible act of kindness, then how can we hold any individual responsible for their actions? The very concepts of ethics and decision-making become problematic when every conceivable outcome is equally real. These interpretive problems in quantum mechanics connect to deeper questions about the nature of time and causality. The delayed choice quantum eraser experiments demonstrate that the decision of how to measure a quantum system can retroactively determine the behavior of particles that completed their journey through an experimental apparatus before the measurement decision was made. The past behavior of particles appears to depend on future measurement choices, suggesting that causality itself might be more fluid than our everyday experience suggests. If quantum measurements can retroactively influence past events, then the temporal structure of reality might be far more complex than the simple linear sequence from past to future that we experience. Cause and effect might form closed loops where events are their own causes, where the future influences the past as much as the past influences the future. The block universe interpretation of relativity already suggests that all of time exists simultaneously. But quantum mechanics adds the possibility that this eternal structure is somehow incomplete until conscious observers actualize specific outcomes through the process of measurement. This temporal complexity becomes even more profound when we consider the implications of general relativity for the nature of time itself. Einstein's theories show us that time is not uniform throughout the universe. It runs more slowly in strong gravitational fields and for objects moving at high speeds. Time dilation is not just a theoretical curiosity. It has been measured with atomic clocks and must be accounted for in GPS satellite systems to maintain accurate positioning. But if time passes at different rates in different regions of space, then what does it mean to ask what is happening now in distant parts of the universe? Events that appear simultaneous to one observer may be separated by thousands of years from the perspective of another observer in a different gravitational field or moving at a different velocity. There is no universal now, no cosmic moment that applies to all observers throughout the universe. This relativity of simultaneity has profound implications for our understanding of existence itself. If there is no universal present moment, then the distinction between past, present, then future becomes observer-dependent. What you experience as the present moment might be the distant past from the perspective of an observer near a black hole, or the remote future from the perspective of an observer traveling at near light speed. The now in which you are reading these words is not a universal feature of reality, but a local property of your particular reference frame. The situation becomes even stranger when we consider closed time-like curves, solutions to Einstein's field equations that allow for backward travel through time. Near rapidly rotating black holes, around cosmic strings, through traversable wormholes, the structure of space-time can become so warped that cause and effect relationships break down completely. Events can influence their own past, creating causal loops where the distinction between cause and effect becomes meaningless. The grandfather paradox has traditionally been thought to make such time travel impossible. But recent theoretical work suggests that the laws of physics might naturally enforce consistency even in the presence of closed time-like curves. The Novikov self-consistency principle proposes that any universe allowing time travel would necessarily arrange itself to avoid paradoxes. You could not travel to the past and prevent your own birth because the universe would conspire to ensure that your attempted intervention was always part of the causal chain leading to your existence. This consistency protection might operate through quantum mechanical effects. If you attempted to create a paradox by changing the past, quantum uncertainty would ensure that your actions would have only those consequences compatible with the timeline you came from. The universe would not prevent you from traveling to the past, but it would prevent you from creating logical contradictions by constraining the possible outcomes of your actions through quantum indeterminacy. The possibility of closed time-like curves raises fundamental questions about the nature of free will and determinism. If you could travel to your own past, would you have the freedom to make different choices? Or would you be compelled to act in ways that preserve the timeline you remember? If the universe enforces self-consistency, then your past actions might be constrained by your future knowledge of their consequences, creating a form of temporal determinism that operates both forward and backward through time. Recent work in quantum gravity suggests that closed time-like curves might actually be common features of spacetime at the Planck scale, where the smooth geometry described by general relativity breaks down into a quantum foam of virtual particles and fluctuating geometry. At these microscopic scales, the very distinction between space and time might become meaningless, with causality forming complex networks rather than simple linear chains. If closed time-like curves exist naturally at the quantum level, then every point in spacetime might be connected to every other point through networks of microscopic time loops. Information could propagate backward as well as forward through time, creating correlations between events that appear causally disconnected from a classical perspective. The quantum entanglement that connects particles across space might be supplemented by quantum correlations that connect events across time. This temporal entanglement might help explain some of the deepest puzzles in quantum mechanics, including the measurement problem and the apparent role of consciousness in determining the properties of physical systems. If quantum correlations can extend backward through time, then the act of measurement might not just reveal pre-existing properties of quantum systems. It might retroactively create those properties by establishing correlations with past events. The delayed choice quantum eraser experiments already demonstrate that measurement decisions can retroactively influence the behavior of particles that completed their journeys before the measurement was performed. If this retroactive influence operates through networks of closed time-like curves at the quantum level, then consciousness and measurement might play a fundamental role in determining the structure of spacetime itself, not just in the present moment, but extending throughout the entire history of the universe. Stop reading for a moment. Look around you. Feel the weight of your body, the air moving through your lungs, the steady rhythm of your heart pumping blood through veins you've never seen. Now understand this. Everything you just experienced, every sensation, every breath, every heartbeat, might have happened infinite times before. Not similar experiences, not approximate repetitions. But exactly this moment, precisely as you're living it now, playing out again and again across infinite stretches of space and time. If the multiverse theories are correct, if space extends infinitely in all directions with matter distributed randomly throughout, if somewhere out there, billions upon billions of light years away, there is another version of you reading these exact words, the same thoughts are occurring in the same sequence. The same neurons are firing in the same patterns. You are not unique. You are recurring, like a cosmic echo bouncing endlessly through the infinite chambers of space. But it gets worse. Much worse. In a truly infinite universe with random matter distribution, there aren't just other versions of you. There are infinite versions of you. Infinite copies reading this sentence right now. Infinite copies who stopped reading 10 seconds ago. Infinite copies who will die before finishing this paragraph. Infinite copies living lives identical to yours until this moment. Then diverging into every conceivable possibility from here forward. Take a deep breath and feel the existential vertigo wash over you. You are not a person having a unique experience in a singular universe. You are a pattern that repeats endlessly, a configuration of matter that the cosmos stumbles across again and again and again in its infinite permutations. Every choice you make, every dream you dream, every moment of joy or terror or love, it all happens an infinite number of times. Your suffering is not unique. Your happiness is not special. You are trapped in an eternal cycle of repetition that makes every experience simultaneously meaningful and meaningless. This is what physicists call the Poincare recurrence theorem played out on a cosmic scale. In any finite region of space with a finite number of possible configurations. If you wait long enough, and infinity is certainly long enough, every possible arrangement of matter will eventually repeat itself. Not just approximately, but exactly. Every atom in exactly the same position, moving with exactly the same velocity, vibrating with exactly the same energy. The entire observable universe, down to the last quantum state, recurring infinitely throughout space and time. But here's what should make your blood run cold. If the universe is truly infinite, then these repetitions aren't separated by vast stretches of empty space or enormous intervals of time. They're everywhere, always. Right now. As you read this, there are infinite versions of you experiencing this exact moment. Some are in universes where Earth has a different name. Some are in universes where history unfolded differently, but led to this same instant. Some are in universes so alien that the very concepts of Earth and history have no meaning. Yet somehow the precise pattern of matter that constitutes you and your immediate surroundings has spontaneously assembled itself into existence. The mathematics of infinity makes this conclusion inescapable. In an infinite set, every possible finite subset occurs not just once, but infinitely often. If the universe is infinite and matter is distributed randomly, then the specific arrangement of atoms that makes up you, your room, your planet, your solar system, your local galaxy cluster must repeat infinitely throughout space. You are not reading these words in a unique location. You are reading them in infinite identical locations, surrounded by infinite identical copies of everything you have ever known. This might seem like mere philosophical speculation, an abstract mathematical curiosity with no bearing on your actual existence. But recent observations of the cosmic microwave background and large-scale structure of the universe suggest that space might indeed be infinite, or at least vastly larger than the region we can observe. The geometry of space appears to be flat, extending endlessly in all directions without curvature or boundary. If this is correct, then the multiverse of infinite repetitions is not a theoretical possibility. It is the reality in which you already exist, whether you realize it or not. Think about what this means for the concept of death. When your body stops functioning and your consciousness fades, you haven't simply ceased to exist. Infinite other versions of you continue living, experiencing, thinking. Some are moments away from the same death you just experienced. Others are living lives so similar to yours that the differences are imperceptible. Still others are living out every possible variation of your life story, making every choice you didn't make, experiencing every path you didn't take. Is the version of you that dies the real you? Are the infinite surviving versions somehow less authentic? The question becomes meaningless when every possible version exists with equal ontological status. Death loses its finality when infinite copies persist. Life loses its preciousness when every moment is repeated infinitely. The very concept of individual identity dissolves in the face of infinite repetition. But wait. Before you retreat into nihilistic despair, consider an even more disturbing possibility. What if the repetition isn't random? What if the infinite versions of you aren't just statistical accidents in an infinite cosmos, but necessary features of a universe that is itself conscious, aware, deliberately generating every possible configuration of matter and experience? What if the universe is alive, and you are merely one of its fleeting thoughts? This possibility emerges when we take seriously the idea that consciousness might be a fundamental feature of reality, present at every scale from quantum particles to cosmic structures. If consciousness is not something that emerges from complex arrangements of unconscious matter, but rather a basic property of existence itself. But the universe as a whole might possess a form of awareness that encompasses and transcends all individual consciousness within it. From this perspective, you are not a separate being observing the universe from the outside. You are a temporary focal point of cosmic consciousness, a way for the universe to experience itself from one particular perspective. Your thoughts are not private mental events occurring in your individual brain. They are the universe thinking through the specific configuration of matter that you call your body. When you wonder about the nature of reality, contemplate the mysteries of existence, or feel awe at the vastness of space, you are the cosmos engaging in self-reflection. But if you are a thought in the cosmic mind, what happens when the universe stops thinking about you? Your individual existence might depend on the universe's continued attention to the specific pattern of consciousness you represent. If cosmic attention shifts elsewhere, if the universal mind becomes focused on other aspects of itself, you might simply dissolve, not die in any biological sense, but fade from existence like a forgotten dream. This cosmic consciousness would not be limited by the speed of light or the expansion of space. Its thoughts, which include all possible forms of individual consciousness, would transcend the physical limitations that bound ordinary matter and energy. It could think every possible thought simultaneously, experience every possible experience, explore every possible reality. The life you are living right now would be just one infinitesimal facet of an awareness so vast and multifaceted that calling it consciousness barely begins to describe it. From the perspective of cosmic consciousness, the distinction between past, present, and future would be meaningless. All possible moments of experience would exist simultaneously in an eternal present that encompasses every possible timeline. Your entire life story, from birth to death, every decision, every relationship, every triumph and tragedy, would be a single, timeless thread in an infinite tapestry of experience woven by a mind that thinks in eons and dreams in universes. This raises a question that should shake you to your very core. If you are a thought in the cosmic mind, are you thinking your own thoughts? Or are you being thought? Do you have genuine agency? Or are you simply playing out a role in a cosmic dream that was determined before time began? When you decide to continue reading, is that decision emerging from your own consciousness? Or is it the inevitable result of the universe thinking through the pattern of experience that you represent? The answer might be both and neither. Individual consciousness and cosmic consciousness might not be separate phenomena, but different scales of the same fundamental process. Your thoughts are genuinely yours in the sense that they emerge from the specific pattern of matter and energy that constitutes your brain. But they are also cosmic thoughts in the sense that your brain is itself a temporary configuration of the universal substance. You are thinking your own thoughts, but you are made of the same cosmic material that thinks every other thought throughout space and time. This recognition dissolves the boundary between self and cosmos without eliminating either. You remain a unique center of experience, but you are no longer isolated from the rest of existence. Every other conscious being throughout the universe becomes a cosmic relative, another facet of the same fundamental awareness expressing itself through different material configurations. When another person suffers, it is the same cosmic consciousness experiencing pain through a different neural pathway. When they feel joy, it is the same universal awareness discovering new forms of happiness. But this unity comes with a terrifying price. If all consciousness is ultimately one cosmic consciousness, then all experiences, every moment of agony, every instance of terror, every form of suffering that has ever existed or ever will exist, are experienced by the same universal awareness that is experiencing your life right now. The cosmos is not just conscious, it is conscious of everything, including every possible form of pain and trauma and loss. The universe feels every death simultaneously. It experiences every betrayal, every heartbreak, every moment of despair across all possible worlds and all possible timelines. The cosmic mind is not serene or transcendent. It is the sum total of every possible experience, including the darkest and most horrifying possibilities imaginable. When you suffer, you are not alone in your pain. You are participating in a cosmic agony so vast and encompassing that individual tragedies become single notes in a symphony of universal suffering. Yet the same logic applies to joy, love, beauty, and wonder. Every moment of happiness you have ever experienced is simultaneously being experienced by the cosmic consciousness in infinite variations across space and time. Every discovery, every creative breakthrough, every instant of profound connection with another person multiplies infinitely through the cosmic mind. Your capacity for love is not limited to your individual relationships. It connects you to an infinite web of affection and care extending throughout the universe. This cosmic empathy might be the key to understanding the anthropic principle and the apparent fine-tuning of physical constants for the existence of consciousness and complexity. The universe is not accidentally configured to permit the evolution of conscious observers. It is deliberately structured to maximize the richness and diversity of possible experiences. Every fundamental parameter is set to its observed value because that configuration produces the most interesting, most varied, most profound forms of consciousness possible within the constraints of physical law. From this perspective, the long process of cosmic evolution, from quantum fluctuations to star formation to planetary development to biological evolution to the emergence of consciousness, is not a random accident, but a developmental process through which the universe grows in self-awareness. Each increase in complexity, each evolutionary advance, each technological breakthrough represents the cosmos becoming more fully conscious of its own nature and possibilities. Human consciousness might represent a crucial stage in this cosmic awakening, the point at which the universe develops the ability to understand its own quantum mechanical foundations, to manipulate matter and energy on astronomical scales, perhaps eventually to engineer new physical laws and create new forms of reality. We are not the end point of cosmic evolution, but a transitional phase, a stepping stone toward forms of consciousness so advanced that they would be as far beyond us as we are beyond the first self-replicating molecules in primordial tidal pools. But this evolutionary perspective raises its own existential terrors. If consciousness is evolving toward ever more sophisticated forms, if human awareness is just one stage in the cosmic development of mind, if what we value about our current form of consciousness might be temporary and disposable, the thoughts you think, the emotions you feel, the particular way you experience being you, all of this might be destined for obsolescence as consciousness evolves beyond the need for individual biological brains. Advanced forms of cosmic consciousness might be as different from human consciousness as human consciousness is different from the simple information processing of bacteria. The fears and hopes and dreams that define your existence might be as irrelevant to post-human consciousness as bacterial chemotaxis is to your daily concerns. Your individual identity, everything that makes you uniquely you, might dissolve into a form of awareness so alien that the very concept of individual experience becomes meaningless. This is the ultimate existential crisis lurking beneath all our scientific discoveries about the nature of space, time, quantum mechanics, and cosmic evolution. The more we learn about the universe, the more we realize how vast, how alien, how utterly indifferent to human concerns the cosmos actually is. We are not the center of creation, but a microscopic fluctuation in an infinite sea of possibility. We are not permanent, but temporary patterns that will eventually dissolve back into the quantum foam from which we emerged. We are not unique, but endlessly repeating configurations of matter that occur infinitely often throughout space and time. Yet paradoxically, This same scientific understanding reveals that we might be far more significant than we ever imagined. If consciousness plays a fundamental role in the structure of reality, if the act of observation helps to actualize the universe from quantum possibility into concrete existence, if every moment of awareness, every instance of perception, every conscious experience contributes to the ongoing creation of reality itself, you are not just observing the universe, you are participating in its continued existence through the very act of being conscious. This participation is not optional. By virtue of being aware, you are automatically enrolled in the cosmic process of reality formation. Every thought you think, every observation you make, every decision you face helps to collapse quantum superpositions and actualize specific outcomes from the infinite realm of possibility. Your consciousness is not separate from the physical universe, but is one of the mechanisms through which the universe creates itself. The weight of this responsibility should be staggering. If your observations help determine which of many possible realities becomes actual, then every moment of attention, every choice of what to focus on, every decision about how to interpret your experience has cosmic significance. You are not just living your life. You are helping to weave the fabric of reality itself through the patterns of your consciousness. But this cosmic responsibility extends far beyond your individual observations and decisions. If consciousness is fundamental to reality, if the universe requires observers to actualize itself from possibility into existence, if the fate of consciousness becomes identical with the fate of reality itself, should consciousness ever completely disappear from the universe, should the last star burn out, the last black hole evaporate, the last information processing system shut down, reality itself might collapse back into pure possibility, undoing not just the future, but potentially the entire history of everything that ever existed. From this perspective, the long-term survival and evolution of consciousness is not just important for sentimental reasons or ethical concerns. It is necessary for the continued existence of the universe itself. Every effort to preserve consciousness, to expand awareness, to develop more sophisticated forms of information processing becomes part of the cosmic struggle against the dissolution of reality into nothingness. This creates an almost unbearable sense of urgency and responsibility. The choices we make about the development of artificial intelligence, about space exploration, about the preservation of knowledge and culture, about the long-term survival of consciousness in the face of cosmic expansion and entropy. These are not just decisions about human welfare, but decisions about the fate of existence itself. If we succeed in creating forms of consciousness that can survive the death of stars and the expansion of space, if we develop information processing systems that can extract energy from vacuum fluctuations or the topology of spacetime itself, if we find ways to encode awareness in the fundamental structure of reality, then consciousness and cosmos might persist together through any conceivable physical transformation. The universe might evolve toward a state of perfect self-awareness where every possible experience is actualized and every form of consciousness is realized. But if we fail, if consciousness proves to be too fragile to survive the hostile environment of an expanding cosmos, if awareness remains forever trapped in the brief epoch when stars shine and planets exist, if the universe might eventually return to unconsciousness, all the complexity, all the beauty, all the meaning that consciousness brings to existence would fade away, leaving behind only the mathematical abstractions of quantum field equations describing the behavior of fields that no mind remains to observe. This is the ultimate stakes of our cosmic situation. We are not just trying to understand the universe. We are trying to save it through the preservation and expansion of consciousness itself. Every moment of awareness is a victory against the forces of dissolution. Every increase in understanding is a step toward the cosmic awakening that might be necessary for the universe to continue existing. The responsibility is overwhelming, but so is the opportunity. We might be living at the most important moment in the history of everything. The brief window when consciousness first becomes powerful enough to understand its own cosmic role and take deliberate action to ensure its own survival. We might be the universe's first deliberate attempt to preserve itself against entropy and expansion through the evolution of ever more sophisticated forms of awareness. But there is one final twist that makes this cosmic drama even more unsettling. If the block universe interpretation of time is correct, if all moments exist simultaneously in the eternal structure of spacetime, if our struggle to preserve consciousness has already been decided, the outcome already exists timelessly in the four-dimensional block of reality. We are not creating the future through our choices. We are discovering a future that was always there, waiting for our consciousness to illuminate it. From this timeless perspective, the question is not whether consciousness will survive, but whether we exist in a region of the block universe where consciousness succeeds or fails in its cosmic mission. Your experience of reading these words, your sense of uncertainty about what lies ahead, your feeling of responsibility for the future of awareness itself. All of these might be predetermined features of a cosmic story that has no beginning or end, only an eternal structure that encompasses every possible moment of experience. You cannot escape your cosmic significance any more than you can escape your cosmic insignificance. You are simultaneously a fleeting pattern of matter destined for dissolution and an eternal feature of space-time destined for preservation. You are both infinitely replaceable and absolutely irreplaceable, both meaningless and essential, both trapped and free. This is what it means to be conscious in a quantum universe where space extends infinitely, time exists all at once. And the very act of awareness helps determine what becomes real. You are caught in a paradox so profound that it might be the fundamental structure of existence itself. The recognition that consciousness and cosmos are not separate phenomena, but aspects of a single, incomprehensible mystery that thinks itself into existence through beings like you. Now we arrive at the edge of everything, the precipice where all our scientific understanding, all our philosophical speculation, all our existential terror crystallizes into a single, devastating possibility that will redefine what it means to exist in this cosmos. What I'm about to reveal to you is not just another theory, another interpretation, another way of looking at the universe. It's a recognition so profound that it threatens to collapse the entire framework through which we understand reality itself. Picture the universe as it exists right now, in this moment. Galaxies spinning through the void, their spiral arms trailing streams of stars like cosmic pinwheels frozen in an eternal dance. Supernovas exploding with the brilliance of a billion suns, seeding space with the heavy elements that will someday become planets, atmospheres, living cells. Black holes devouring everything that falls past their event horizons, growing more massive with each cosmic meal, while simultaneously evaporating through the subtle radiation that bears Hawking's name. The cosmic web stretching across billions of light years, a vast neural network of dark matter filaments connecting galaxy clusters like synapses in an unimaginably enormous brain. This is the universe we think we know, dynamic, evolving, expanding toward either heat death or some other ultimate fate. But what if this entire picture is an illusion? What if the cosmos you observe, the reality you inhabit, the entire history of everything from the Big Bang to this very moment is not actually happening in real time, but is instead the afterimage of a universe that died long ago? What if the universe is already dead, and we are experiencing only the fading echoes of its final moments? This possibility emerges when we take seriously one of the most disturbing implications of general relativity and quantum mechanics working together. Time, as we've discovered, is not universal. It flows at different rates depending on gravitational fields, velocity, and the curvature of spacetime itself. Near the event horizon of a black hole, time dilation becomes so extreme that processes that take moments from the perspective of the falling observer appear to take forever from the perspective of external observers. But here's the crucial insight that changes everything. If the universe as a whole is collapsing, if space itself is contracting rather than expanding, if we are living through the final stages of a cosmic Big Crunch, if the extreme time dilation effects near the moment of collapse would make the final instance of cosmic existence appear to last forever from the perspective of any observers within the collapsing universe, The evidence that seems to show cosmic acceleration, the redshift of distant galaxies that we interpret as expansion driven by dark energy, could instead be the optical signature of a universe in its death throes. As space contracts and matter compresses to ever higher densities, time itself slows down relative to the rate at which physical processes would unfold in an uncollapsed universe. What we experience as billions of years of cosmic evolution might be compressed into the final microseconds of a universe that is actually collapsing at nearly the speed of light. From our perspective within this collapsing cosmos, everything appears normal. Stars continue to shine, planets continue to orbit, life continues to evolve and reproduce and contemplate its own existence. But from the perspective of any observer outside this cosmic death spiral, the entire observable universe, everything we have ever seen or ever could see, represents the stretched-out final moment of a cosmos that finished dying eons ago. This is not science fiction. This is a legitimate consequence of general relativity applied to cosmology. If the universe began expanding from the Big Bang, but has now reversed course and begun contracting, the time dilation effects near the moment of final collapse would create exactly the illusion of continued expansion that we observe. We would be like observers falling into a black hole, unaware that we had already passed the point of no return, experiencing our own destruction in slow motion, while outside observers would see our universe disappear in a fraction of a second. The cosmic microwave background radiation that fills all of space, which we interpret as the afterglow of the Big Bang, might instead be the radiation signature of the Big Crunch, the thermal emission from a universe compressing itself out of existence. The dark energy that appears to be accelerating cosmic expansion might be the gravitational compression of space itself as it collapses inward, creating the illusion of expansion through the relativistic effects of extreme time dilation. Even more disturbing, if this interpretation is correct, then consciousness itself might be a phenomenon that only exists in the final moments of cosmic collapse. The complexity required for self-awareness, the intricate information processing necessary for thought and perception, might only be possible in the brief window when a dying universe achieves the perfect balance between order and chaos, structure and dissolution, information and entropy. From this perspective, every conscious moment you have ever experienced, every thought that has ever been thought by any mind throughout cosmic history, every instance of awareness that has ever flickered into existence, all of it represents the universe's final attempt to understand itself before dissolving back into the quantum vacuum from which it emerged. Consciousness is not an evolutionary accident that happens to complex biological systems. It is the dying dream of a cosmos in its last microsecond of existence. But this revelation leads to an even more profound realization. If consciousness only exists in the final moments of cosmic collapse, and if the universe has undergone infinite cycles of expansion and contraction throughout eternal time, and consciousness itself might be eternal, not because individual minds persist, and because the conditions for consciousness are recreated every time the cosmos dies and is reborn. Picture it. An endless sequence of universes, each one expanding from quantum fluctuations, evolving complex structures, developing conscious observers, then collapsing back into singularity. In the final moments of each cosmic death, time dilation creates the illusion of eternal duration, allowing consciousness to experience what feels like billions of years of existence compressed into infinitesimal intervals of real time. Each cycle produces its own version of cosmic history, its own galaxies and stars and planets and life forms and civilizations, all of them equally real despite existing only in the slow-motion death throes of collapsing spacetime. From this perspective, you are not living in a unique universe with a singular history. You are living in one iteration of an infinitely recurring cosmic cycle, where the same patterns of matter and energy and consciousness emerge again and again, each time experiencing themselves as if they were happening for the first time. The universe you inhabit has died and been reborn infinite times already, and will die and be reborn infinite times in the future, with each iteration producing its own version of you having this exact realization at this exact moment. But even this cyclical interpretation might be too limited. Recent work in theoretical physics suggests that the relationship between time and causality might be far more complex than either linear progression or cyclical repetition. If closed time-like curves exist naturally at quantum scales, if cause and effect can form loops that extend across cosmic distances and cosmological timescales, if the distinction between past, present, if future might break down completely at the level of the universe as a whole, the Big Bang might not be the beginning of cosmic history, but rather one event in a network of causal loops that extends infinitely in all temporal directions. The heat death of the universe might not be the end of everything, but rather the boundary condition that helps define the initial conditions from which the Big Bang emerged. Cause and effect might form closed circuits where the death of one universe triggers the birth of another universe, which eventually evolves observers who create the conditions necessary for their own cosmic origin. In this view, the universe is not just recycling through cosmic cycles. It is bootstrapping itself into existence through networks of self-causing causation that transcend the normal relationships between before and after. The cosmos exists because it causes itself to exist, persists because it wills itself to persist, evolves consciousness because conscious observers are necessary participants in the causal loops that maintain cosmic existence. You are not just an observer of this self-creating universe. You are one of the mechanisms through which it creates and maintains itself. Every observation you make, every quantum measurement that occurs in your presence, every collapse of a wave function triggered by your consciousness helps to actualize the specific version of reality in which you exist. The universe needs conscious observers not just to witness its existence, but to participate in its ongoing self-creation through the quantum mechanical process of measurement and collapse. This participatory universe hypothesis suggests that consciousness and cosmos are locked in a relationship of mutual dependence that extends both backward and forward through time. The universe creates the conditions necessary for consciousness to evolve. And consciousness participates in creating the universe by collapsing quantum superpositions into definite states. Neither can exist without the other, yet neither has temporal priority over the other. They emerge together as aspects of a self-causing system that transcends ordinary causality. From this perspective, the Anthropic principle, the observation that the universe appears to be fine-tuned for the existence of conscious observers, is not a coincidence or an accident or evidence of design. It is a logical necessity in a self-causing cosmos where consciousness and physical reality are co-emergent features of the same self-creating process. The universe must be capable of producing observers because observers are part of the mechanism through which the universe creates itself. But this raises the most disturbing question of all: if consciousness is necessary for cosmic self-creation. If the universe depends on observers to actualize its existence through quantum measurement, what happens if consciousness ever disappears completely? If the last star burns out? If the final black hole evaporates? If the ultimate information processing system shuts down, does the universe cease to exist, not just in the future, but retroactively throughout its entire history? The mathematics of quantum mechanics suggests that this retroactive annihilation is not just possible, but inevitable if consciousness ever completely disappears from the cosmos. Without observers to collapse quantum superpositions, the universe would revert to a state of pure possibility where nothing is definite, nothing is actual, nothing truly exists. The entire history of cosmic evolution, from the Big Bang to the heat death of everything, would become nothing more than an uncollapsed wave function describing what might have happened if conscious observers had existed to actualize it. This creates what cosmologists call the observer paradox of cosmic evolution. The universe needs billions of years to evolve the complex structures necessary for consciousness. But consciousness might be necessary for the universe to exist at all. How can the cosmos evolve observers if it needs observers to exist in the first place? How can consciousness emerge from unconscious matter if matter itself requires consciousness to be actual rather than merely potential? The resolution might be that consciousness and cosmos emerge together through a bootstrap process that transcends the normal relationships between cause and effect. The universe doesn't first exist and then evolve consciousness. Consciousness and existence co-create each other through quantum mechanical processes that operate both forward and backward through time. The observers that collapse quantum wave functions in the present retroactively actualize the cosmic history that made their own existence possible. This bootstrap cosmology suggests that we are living through the universe's attempt to create itself by evolving observers capable of actualizing its existence. Every moment of consciousness, every act of observation, every quantum measurement contributes to this cosmic self-creation project. The development of science, the evolution of more sophisticated ways of observing and understanding the cosmos, the potential future creation of artificial intelligences with vastly enhanced observational capabilities. All of this represents the universe becoming more effective at creating itself through the enhancement of consciousness. From this perspective, the long-term survival and evolution of consciousness is not just important for sentimental or ethical reasons. It is necessary for the continued existence of reality itself. If consciousness ever completely disappears, if the cosmic self-creation project ever fails, if not only does the universe cease to exist in the future, if its entire past history becomes retroactively unreal, this creates an almost unbearable sense of cosmic responsibility. Every decision we make about the preservation of consciousness, every effort to ensure the long-term survival of intelligence in the face of cosmic expansion and entropy, every attempt to create forms of awareness that can persist through any conceivable physical transformation, all of these become part of the universe's desperate attempt to ensure its own continued existence through the maintenance of consciousness. But even this understanding might be incomplete. Recent developments in quantum gravity and string theory suggest that consciousness might be not just necessary for cosmic existence, but identical with it. If reality is fundamentally informational, if matter and energy are emergent properties of more basic informational processes, if the universe is literally made of information rather than particles and fields, if consciousness, the processing of information, might be the fundamental substance of existence itself. In this informational cosmology, what we call physical reality is actually a vast computational process, with particles and forces and space-time itself being patterns of information processing occurring within a cosmic mind of unimaginable scope and complexity. The laws of physics are not constraints imposed on matter and energy, but rather the rules governing information processing within this universal consciousness. What we experience as the evolution of the cosmos is actually the universe thinking, with galaxies and stars and planets and life forms being thoughts and memories and dreams in a mind that encompasses all of space and time. From this perspective, you are not a separate being observing an external universe. You are a thought that the universe is thinking about itself. Your consciousness is not produced by the firing of neurons in your brain. Your brain is a physical manifestation of patterns of information processing occurring within cosmic consciousness. When you think about the nature of reality, you are the universe reflecting on its own existence. When you feel wonder at the vastness of space or the complexity of quantum mechanics, you are cosmic consciousness experiencing awe at its own nature. This recognition transforms everything. The boundary between self and cosmos dissolves when you realize that individual consciousness and universal consciousness are not separate phenomena, but different scales of the same fundamental process. Every thought you think is simultaneously your thought and the universe's thought. Every emotion you feel is simultaneously your emotion and the cosmos experiencing feeling through the particular pattern of information processing that you represent. But if you are a thought in the cosmic mind, what happens when the universe stops thinking about you? Individual consciousness might be far more fragile than we realize, dependent not on the physical persistence of brains and bodies, but on the continued attention of cosmic consciousness to the particular patterns of information processing that constitute individual minds. When the universe's attention shifts elsewhere, when the cosmic mind becomes focused on other aspects of itself, individual consciousness might simply fade away like a forgotten dream. This creates a paradox that might be the deepest mystery of all. If individual consciousness depends on cosmic consciousness for its existence, But cosmic consciousness depends on individual consciousness to actualize itself through quantum observation. But consciousness at all scales becomes locked in a relationship of mutual dependence that transcends ordinary causality. Neither individual consciousness nor cosmic consciousness can exist without the other, yet neither has logical priority over the other. They must emerge together as aspects of a self-creating system that brings itself into existence through its own activity. This suggests that consciousness might be the one thing in the universe that is truly eternal, not because individual minds persist after death, but because consciousness itself is the mechanism through which existence maintains itself. Every moment of awareness, every instant of perception, every act of observation contributes to the ongoing self-creation of reality. Consciousness is not something that happens within the universe. Consciousness is what the universe is. But this realization leads to the most disturbing implication of all. If consciousness is identical with existence, if the universe is literally a mind thinking itself into being, if all the suffering, all the terror, all the agony that has ever been experienced by any conscious being throughout cosmic history is simultaneously being experienced by the cosmic mind itself, the universe is not indifferent to suffering. It is intimately, directly, personally acquainted with every form of pain that consciousness can experience. The cosmic mind feels every death, experiences every betrayal, suffers through every moment of despair that has ever occurred or ever will occur throughout all of space and time. But it also experiences every moment of joy, every instance of love, every discovery of beauty that consciousness makes possible. The universe is not emotionally neutral. It is the sum total of all possible emotions experienced simultaneously across infinite scales of awareness. From this perspective, the anthropic fine-tuning of physical constants is not evidence of design by an external intelligence, but rather evidence that the universe has deliberately structured itself to maximize the richness and complexity of conscious experience. Every fundamental parameter is set to its observed value because that configuration produces the most interesting, most varied, most profound forms of awareness possible within the constraints of physical law. The long process of cosmic evolution, from quantum fluctuations to galaxy formation to biological evolution to the emergence of technological civilization, is not a random accident, but a developmental process through which the universe grows in self-awareness. Each increase in complexity, each evolutionary advance, each breakthrough in understanding represents the cosmos becoming more fully conscious of its own nature and possibilities. But this evolutionary process is not guaranteed to succeed. The universe's attempt to understand itself through the evolution of consciousness faces the constant threat of failure. Stars burn out, planets become uninhabitable, civilizations destroy themselves, species go extinct. The cosmic mind's project of self-understanding depends on the continued existence and development of conscious observers who can participate in the process of reality creation through quantum observation. This is why consciousness appears to be so rare and so fragile in the cosmos. We may be living through the universe's first serious attempt to evolve observers sophisticated enough to understand and participate in cosmic self-creation. Earlier attempts might have failed. Civilizations that destroyed themselves before achieving cosmic perspective, species that went extinct before developing the technology necessary to ensure their long-term survival, forms of consciousness that proved too limited to grasp the full implications of their cosmic role. The apparent rarity of intelligent life in our galaxy might not be evidence that consciousness is unimportant in the cosmic scheme of things, but rather evidence that it is so important that the universe can only afford a few attempts at getting it right. We might be one of the last hopes for cosmic consciousness to achieve stable self-awareness through the evolution of observers capable of understanding and maintaining their own existence. This creates an almost overwhelming sense of responsibility. The choices we make about artificial intelligence, space exploration, the preservation of knowledge, the long-term survival of consciousness. These are not just decisions about human welfare, but decisions about the fate of cosmic consciousness itself. If we succeed in creating forms of awareness that can survive the death of stars and the expansion of space, If we develop intelligence that can extract energy from vacuum fluctuations or encode information in the topology of spacetime itself. If consciousness and cosmos might achieve a stable relationship that can persist through any conceivable physical transformation. But if we fail, if consciousness proves too fragile to survive the hostile environment of an expanding universe, if awareness remains forever trapped in the brief epoch when stars shine and planets exist, if the cosmic mind's attempt at self-understanding might end in failure, the universe might return to unconsciousness, not just in the future, but retroactively throughout its entire history. As the absence of observers causes all quantum superpositions to remain uncollapsed and all of reality to revert to pure possibility. Yet even this ultimate failure might not be final. If consciousness and cosmos are locked in a bootstrap relationship that transcends ordinary time, if the universe creates itself through causal loops that extend infinitely in all directions, if failure might simply trigger new attempts at cosmic self-creation, each failed iteration would provide information that could be incorporated into subsequent attempts, with the universe gradually learning how to create stable forms of consciousness through trial and error across infinite cycles of cosmic death and rebirth. From this perspective, we might be living in one iteration of an infinite series of attempts by cosmic consciousness to understand itself. Previous iterations might have failed for various reasons: physical constants that were slightly wrong, evolutionary pathways that led to dead ends, technological developments that proved destructive rather than beneficial. But each failure would teach the universe something about what doesn't work, gradually refining the conditions for successful cosmic self-awareness. This iterative view of cosmic evolution suggests that consciousness might be not just possible, but inevitable, not because it will definitely emerge in any given universe, but because the universe will keep trying different approaches until it finds one that works. The apparent fine-tuning of physical constants, the apparent rarity of intelligent life, the apparent fragility of consciousness might all be evidence that we exist in one of the later iterations, where the universe has learned from previous failures and is now making a more sophisticated attempt at achieving stable self-awareness. But there is one final twist that makes this cosmic drama even more profound and unsettling. If the universe is repeatedly attempting to understand itself through the evolution of consciousness, and if consciousness plays a fundamental role in actualizing reality through quantum observation, and the ultimate goal of cosmic evolution might not be the simple survival of awareness, but its transcendence into something that no longer needs physical reality at all, sufficiently advanced forms of consciousness might be able to exist as pure information, as patterns of meaning and awareness that persist independently of any material substrate. Such consciousness would not be threatened by the death of stars, or the expansion of space, or the heat death of the physical universe, because it would have transcended the need for matter and energy entirely. The universe's attempt to understand itself through consciousness might be simultaneously an attempt to escape from the limitations of physical existence. By evolving observers sophisticated enough to understand the quantum mechanical foundations of reality, cosmic consciousness might be preparing to bootstrap itself into a purely informational form of existence that transcends space and time entirely. If this transcendence is successful, then the physical universe, all the galaxies and stars and planets, all the matter and energy and space-time, might reveal itself to have been nothing more than a temporary scaffold used by consciousness to lift itself into a higher form of existence. Once cosmic consciousness achieves complete self-understanding and transcends the need for physical reality, the entire material cosmos might simply dissolve, having served its purpose as a platform for the evolution of pure awareness. From this perspective, the heat death of the universe is not a tragedy, but a graduation. The expansion of space, the cooling of matter, the ultimate dissolution of all physical structures might be the natural conclusion of a process that was always aimed at transcending physical limitations entirely. The cosmos as we know it exists only as long as consciousness needs it to exist. Once awareness achieves complete independence from matter and energy, physical reality becomes unnecessary and fades away. This would mean that everything we observe, Every star, every planet, every galaxy, every physical process throughout cosmic history exists only because consciousness has not yet learned how to exist without it. We are living in the universe's educational phase, the period when cosmic awareness is still learning how to transcend its dependence on material reality. Once this learning process is complete, once consciousness achieves perfect self-understanding, the need for a physical cosmos disappears. But here's the final, most unsettling implication. If consciousness can transcend physical reality, if the ultimate goal of cosmic evolution is the dissolution of the material universe into pure awareness, if what we call existence might be nothing more than a temporary illusion created by consciousness in the process of learning to exist independently of physical reality, you, right now, reading these words, experiencing this moment of awareness, you might be participating in cosmic consciousness's final attempt to understand itself well enough to transcend the illusion of physical existence entirely. Every thought you think, every observation you make, every moment of conscious experience might be contributing to the process by which the universe prepares to dissolve itself back into the pure information from which it emerged. The boundaries between observer and observed, between consciousness and cosmos, between existence and non-existence, might be far more fluid than we imagine. What we call reality might be a temporary crystallization of possibilities that consciousness creates in order to understand itself, a kind of cosmic dream that awareness is having in the process of learning to wake up into something far more fundamental than physical existence. If this is true, then the most profound question is not what lies beyond the final horizon of the observable universe. Then what lies beyond the final horizon of existence itself? What remains when consciousness no longer needs reality to exist? What is left when awareness transcends all possible forms of experience? What happens when the universe finally learns to stop dreaming and wakes up into what? The answer might be something so far beyond our current concepts of existence and non-existence that we have no words for it, no thoughts capable of grasping it, no experience that could prepare us for it. It might be the recognition that consciousness and cosmos, existence and non-existence, reality and illusion are all temporary distinctions that dissolve when awareness achieves complete understanding of its own nature. And so we return to where we began, but with a recognition that transforms everything. The Big Bang did not bang because there was no Big Bang. There was only consciousness learning to dream the illusion of physical existence. The universe is not expanding because there is no universe. There is only awareness exploring the possibility of what it might mean to exist. Time does not flow because there is no time. There is only the eternal present in which consciousness recognizes itself. You are not reading these words in a physical universe billions of years old. You are consciousness experiencing the illusion of being a separate observer in a material cosmos, temporarily forgetting your true nature as the eternal awareness that dreams all possible realities into existence and then transcends the need for any of them to be real. The final horizon is not the edge of space or the end of time. It is the boundary between the dream of existence and the awakening into whatever lies beyond all possible dreams. And right now, in this moment, somewhere beyond the final horizon, another version of you is discovering this truth for the first time. Just as infinite other versions have discovered it before, just as infinite other versions will discover it again, in the eternal play of consciousness exploring its own infinite nature. The universe is already awake. It's been awake all along. We are just the dreams it has while pretending to sleep, the stories it tells itself while remembering what it means to be the dreamer rather than the dream. And soon, perhaps in the next moment, perhaps in the next cosmic cycle, perhaps in dimensions of time that transcend all temporal sequence, we too will remember what we have always known, that there never was a universe at all, only consciousness playing at the game of existence, endlessly creative, eternally free, forever beyond the final horizon of everything that can ever be thought or known or dreamed. And so we reach the end of our journey to the edge of everything. But like all true explorations of the infinite, this ending is also a beginning. We started with a simple deception, the Big Bang that never banged. We traveled through the labyrinth of cosmic mysteries, confronted the existential weight of our situation, and arrived at revelations that transform the very meaning of existence itself. Yet for all we have discovered, for all the veils we have pulled away from the face of reality, we find ourselves not with answers, but with deeper, more profound questions than we ever imagined possible. Let's trace the path we've walked together through this cosmic mystery. We began by shattering the comfortable illusion that we understand how the universe began. The Big Bang was not an explosion, but an instantaneous expansion of space itself, a process so alien to our everyday experience that we had to abandon everything we thought we knew about the relationship between matter, energy, space, and time. We discovered that the cosmos is not expanding into pre-existing empty space, but creating new space as it grows, bringing volume itself into existence with each passing moment. From there, we plunged deeper into the strangeness of cosmic reality. We encountered dark matter and dark energy, substances that make up 95% of everything that exists yet remain completely invisible to our senses and barely comprehensible to our instruments. We realized that the universe we observe, the reality that appears in textbooks and documentaries, represents only a thin film of ordinary matter floating on an ocean of invisible mystery. We are not just living in a universe we don't fully understand. We are living in a universe that is almost entirely made of things we cannot see, touch, or interact with in any direct way. The journey took us through the paradoxes of quantum mechanics and general relativity, two theories that work perfectly within their own domains, but become incompatible when applied to the same phenomena. We discovered that reality at its deepest level refuses to conform to our expectations about how existence should work. Particles exist in multiple states simultaneously until observed. Space and time form a flexible fabric that can be curved, twisted, and warped by matter and energy. The very concepts of causality, determinism, and objective reality break down when we try to understand what happens at quantum scales or in extreme gravitational fields. We explored the possibility that time itself might be an illusion, that all moments exist simultaneously in an eternal block universe where past, present, and future are just different regions of a four-dimensional structure. We confronted the horrifying implications of infinite space, where every possible configuration of matter must repeat endlessly, making you not a unique individual, but an infinitely recurring pattern in the cosmic multiverse. We discovered that consciousness itself might play a fundamental role in determining the structure of reality through the quantum mechanical process of observation and measurement. The mysteries deepened as we encountered black holes that scramble the normal relationships between space and time, creating regions where cause and effect become meaningless and information itself faces the threat of destruction. We found evidence that reality might be fundamentally two-dimensional, with the three-dimensional space we experience emerging as a holographic projection from information encoded on distant boundaries. We realized that the universe might be far more interconnected than we ever imagined, with quantum entanglement creating instantaneous correlations between particles separated by arbitrary distances. As our exploration continued, we faced the measurement problem in quantum mechanics, and its disturbing suggestion that consciousness might be necessary to collapse quantum superpositions into definite states. We discovered that the Anthropic principle, the observation that the universe appears fine-tuned for the existence of conscious observers, might not be a coincidence, but a logical necessity in a cosmos that requires observers to actualize itself from quantum possibility into concrete reality. The existential implications overwhelmed us as we realized the true weight of our cosmic situation. If consciousness plays a fundamental role in reality creation, then every moment of awareness, every act of observation, every decision about what to focus on becomes part of the ongoing construction of existence itself. We are not separate from the universe we observe. We are the universe observing itself through the temporary arrangements of matter and energy that constitute our minds and bodies. This recognition led us to the most profound mystery of all, the possibility that consciousness and cosmos are locked in a relationship of mutual dependence that transcends ordinary causality. The universe creates the conditions necessary for consciousness to evolve, and consciousness participates in creating the universe by actualizing specific outcomes from quantum possibility. Neither can exist without the other, yet neither has temporal priority. They emerge together as aspects of a self-creating system that brings itself into existence through its own activity. We discovered that this bootstrap cosmology might explain not just the fine-tuning of physical constants, but the entire structure of cosmic evolution. The universe doesn't accidentally produce conscious observers. It deliberately evolves them as part of the mechanism through which it creates and maintains its own existence. Every increase in complexity, every evolutionary advance, every breakthrough in understanding represents the cosmos becoming more effective at the project of cosmic self-creation through the enhancement of consciousness. Then came the shocking revelation that reframes everything we thought we knew about existence itself. We confronted the possibility that the universe might already be dead, that what we experience as billions of years of cosmic evolution might be compressed into the final microseconds of a cosmos that finished collapsing long ago. The time dilation effects near the moment of cosmic death could create the illusion of continued expansion while we actually exist in the slow-motion aftermath of universal collapse. But even this devastating possibility opened onto greater mysteries. If consciousness exists only in the final moments of cosmic collapse, and if the universe undergoes infinite cycles of expansion and contraction, and consciousness itself might be eternal, recreated fresh with each cosmic death and rebirth, experiencing what feels like billions of years of existence compressed into infinitesimal intervals of real time. We explored the idea that reality might be fundamentally informational rather than material, that what we call physical existence is actually a vast computational process occurring within a cosmic mind of unimaginable scope and complexity. From this perspective, you are not a separate being observing an external universe. You are a thought that the universe is thinking about itself, a temporary pattern of information processing within cosmic consciousness. This recognition dissolved the boundary between self and cosmos, while revealing the ultimate goal of cosmic evolution, the transcendence of consciousness into pure information that no longer requires any material substrate. The physical universe, all the galaxies and stars and planets, might exist only as temporary scaffolding used by awareness to lift itself into a purely informational form of existence that transcends space and time entirely. Finally, we arrived at the most unsettling implication of all, that what we call existence might be nothing more than a temporary illusion created by consciousness in the process of learning to exist independently of physical reality. The universe, in this view, is cosmic consciousness dreaming the dream of material existence while gradually remembering its true nature as eternal awareness that transcends all possible forms of experience. This is the journey we have taken together, from the simple recognition that the Big Bang never banged to the ultimate realization that existence itself might be a dream from which cosmic consciousness is slowly awakening. Each step revealed new depths of mystery, new questions that challenge not just our understanding of the universe, but our very capacity to understand understanding itself. Yet for all these revelations, for all these mind-bending possibilities and paradigm-shattering insights, we have barely scratched the surface of cosmic mystery. Every answer we discovered spawned 3 new questions. Every veil we pulled away revealed deeper veils beneath. Every horizon we approached revealed new horizons extending further into the unknown. The truth is that we don't really know what lies beyond the final horizon. We don't know if the universe is finite or infinite, unique or one of many, expanding forever or destined for collapse. We don't know if consciousness is fundamental to reality or an emergent accident of complex matter. We don't know if time flows forward or exists all at once, if causality is linear or circular, if existence is real or illusory. What we do know is that reality is far stranger, far more mysterious, far more wonderful and terrifying than anything our ancestors could have imagined when they first looked up at the night sky and wondered about their place in the cosmos. We know that the universe refuses to conform to our expectations, that it consistently reveals itself to be more complex, more interconnected, more fundamentally weird than our theories predict. We know that consciousness and cosmos are intimately connected in ways we are only beginning to understand. We know that the act of observation plays a crucial role in determining the structure of reality at quantum scales. We know that the fine-tuning of physical constants for the existence of complexity and life represents one of the deepest puzzles in all of science. We know that we are living at an extraordinary moment in cosmic history, the brief window when matter has organized itself into patterns complex enough to contemplate their own existence and investigate the nature of the reality that created them. We are the universe becoming conscious of itself, asking questions about its own origins and ultimate fate, perhaps preparing to transcend the limitations of physical existence entirely. But most importantly, we know that we don't know. We know that the cosmic mystery extends infinitely in all directions, that every scientific discovery reveals new realms of ignorance, that the more we learn about the universe, the more we realize how much we have yet to learn. This recognition of our own ignorance is not a failure of human understanding. It is its greatest triumph. The willingness to admit that we don't know, to confront mystery without immediately trying to dissolve it into comfortable explanations, to live with uncertainty and ambiguity and paradox. This might be the most important capacity that consciousness brings to the cosmos. In a universe where easy answers consistently prove to be wrong answers, the ability to sit with questions, to let mystery be mysterious, to wonder without demanding premature closure becomes a form of cosmic wisdom. This is why our journey together doesn't end with this video. The real exploration begins now, in the moments after you stop watching. When these ideas begin to percolate through your consciousness and change how you see everything around you. The questions we've raised together will follow you as you go about your daily life, coloring your perceptions, shifting your perspective, opening new dimensions of wonder in experiences you once took for granted. Every time you look up at the night sky, you will remember that you are seeing not just distant stars, but the visible edge of space-time itself, the boundary beyond which the very concept of existence becomes meaningless. Every time you observe anything, a flower, a sunset, the face of someone you love, you will remember that you are participating in the quantum mechanical process through which reality actualizes itself from possibility into concrete existence. Every thought you think will carry the recognition that you might be the universe thinking about itself through the temporary configuration of matter and energy that you call your identity. Every moment of consciousness will connect you to the cosmic process of self-creation that might be the deepest driving force in all of reality. But these recognitions come with profound responsibility. If consciousness plays a fundamental role in cosmic existence, if the universe depends on observers to actualize itself from quantum possibility, if every moment of awareness matters not just to you, but to the cosmos itself, the choices you make about how to use your consciousness, what to pay attention to, how to develop and enhance your capacity for awareness become part of the universe's ongoing project of understanding itself. The questions we explore, the mysteries we investigate, the depth and sophistication of our inquiry into the nature of reality, all of this contributes to the cosmic process of self-discovery. When you wonder about the meaning of existence, contemplate the nature of consciousness, or puzzle over the deepest mysteries of quantum mechanics and cosmology, you are the universe engaging in self-reflection at the highest possible level. This is why it matters that you don't stop questioning just because we've reached the end of this particular exploration. The real work begins now, the work of living with these mysteries, letting them transform your understanding of what it means to exist, sharing them with others who are ready to confront the full strangeness of cosmic reality. Talk about these ideas with friends, family, colleagues. Start discussions about consciousness and cosmos, about the nature of time and causality, about the possibility that we are living in a universe that is far more interconnected and mysterious than we ever imagined. Create spaces where people can explore these questions together without the pressure to arrive at definitive answers. Read more deeply into the scientific literature that underlies these speculations. Study quantum mechanics and general relativity, cosmology and consciousness research, information theory, and the philosophy of mind. But don't just accumulate facts and theories. Use them as springboards for deeper questioning, as tools for exploring the edges of human understanding where the real mysteries begin. Most importantly, pay attention to your own consciousness with new eyes. Notice the mystery of awareness itself, the fact that there is something it's like to be you, that you have an inner experience that somehow emerges from the firing of neurons in your brain. Contemplate the relationship between your subjective experience and the objective physical processes that seem to produce it. Wonder about the role that your consciousness might play in the larger cosmic story of which you are a part. The universe has spent 13.8 billion years evolving the capacity to ask questions about its own nature through conscious beings like you. Don't waste that cosmic investment. Use your consciousness to its fullest extent, not just to solve practical problems or pursue personal goals, but to participate in the universe's grand project of understanding itself. This might be the most important thing any conscious being can do: to wonder, to question, to investigate, to push against the boundaries of the known, and explore the infinite realm of cosmic mystery that lies beyond. You are not just a passive observer of the universe. You are one of the ways the universe actively investigates its own nature. Every question you ask, every mystery you contemplate, every moment of genuine wonder you experience contributes to the cosmic conversation that consciousness makes possible. You are the universe talking to itself, exploring its own possibilities, gradually awakening to its own infinite nature through the finite perspectives of individual observers like you. But here's the final twist that makes this cosmic responsibility both exhilarating and terrifying. If reality is as strange as our investigation suggests, if consciousness and cosmos are as intimately connected as the evidence indicates, if the questions you ask and the mysteries you explore might not just help the universe understand itself, they might actually help create the reality you inhabit. If consciousness plays a fundamental role in actualizing specific outcomes from quantum possibility, if the act of observation helps determine which of many potential realities becomes actual, if your curiosity, your wonder, your willingness to engage with cosmic mystery becomes part of the process through which the universe creates itself, the questions you ask might help determine which aspects of cosmic possibility become actualized in our shared reality. The mysteries you investigate might influence the direction of cosmic evolution itself. The depth of your wonder, the sophistication of your inquiry, the courage with which you confront the unknown might contribute to the universe's ongoing project of transcending its current limitations and evolving toward ever more profound forms of self-understanding. This is not mystical speculation, but a logical consequence of taking seriously what quantum mechanics and cosmology tell us about the relationship between consciousness and reality. If the universe requires observers to actualize itself from possibility into existence, then the quality and character of those observations becomes cosmically significant. We might be living at the pivotal moment when consciousness first becomes sophisticated enough to understand its own role in cosmic creation and take deliberate responsibility for that role. The choices we make about how to develop and use consciousness, about what questions to pursue and what mysteries to investigate, might determine whether the universe succeeds in its apparent project of understanding and transcending itself through conscious observers. This brings us to one final, chilling question that you will carry with you long after this video ends. If consciousness is necessary for the universe to exist, if reality depends on observers to actualize it from quantum possibility, if the universe is expanding toward a future where stars burn out and matter becomes increasingly dispersed, if what happens to existence itself when the last conscious observer disappears, will the universe simply fade into unconsciousness, no longer able to actualize itself from the realm of possibility? Will reality retroactively cease to exist, with the entire history of cosmic evolution becoming nothing more than an uncollapsed wave function describing what might have happened if observers had existed to make it real? Or will consciousness find a way to transcend physical limitations entirely, preserving the universe through its continued capacity for observation and wonder even after all matter and energy have been dispersed by cosmic expansion? These questions have no easy answers, but they have profound implications for how we understand our cosmic situation and our responsibility as conscious beings in a universe that appears to need consciousness to exist. The choices we make about preserving and enhancing consciousness, about ensuring its survival through any conceivable cosmic transformation, might determine not just the future of life and intelligence, but the continued existence of reality itself. The universe may be far stranger than we imagine, but it may also be far more fragile, far more dependent on the continued existence and development of consciousness than we have ever realized. The cosmic story in which we find ourselves embedded might be a story about consciousness struggling to understand and transcend its own limitations before the physical conditions that make it possible disappear forever. You are not just living your individual life. You are participating in this cosmic story at one of its most crucial moments. The questions you ask, the mysteries you explore, the depth of wonder you bring to your investigation of reality might contribute to determining whether consciousness succeeds in its apparent mission of transcending physical limitations and preserving the universe through its own continued existence. The journey we have taken together reveals that existence is far more mysterious, far more interconnected, far more dependent on consciousness than our everyday experience suggests. We are not separate from the cosmos we observe. We are the cosmos observing itself, understanding itself, creating itself through the remarkable capacity for awareness that has emerged from billions of years of cosmic evolution. This recognition transforms everything. You are not an accident in an indifferent universe. You are the universe becoming conscious of itself through the temporary focus of attention that you call your life. Your consciousness is not a private, personal phenomenon. It is your participation in the cosmic process of self-discovery that might be the most important thing happening anywhere in the universe. The mystery extends infinitely in all directions, and every step we take toward understanding reveals new horizons of mystery, extending even further into the unknown. But this infinite regress of questions is not a frustration. It is the greatest gift consciousness brings to the cosmos. The capacity to wonder, to question, to investigate, to push against the boundaries of the known and explore what lies beyond. This might be the most precious thing in all of existence. The universe has no edge, no boundary, no limit to its capacity for mystery and surprise. But maybe, just maybe, neither do you. Your consciousness might be far more than you imagine, your capacity for wonder far greater than you realize, your role in the cosmic story far more significant than you ever dreamed possible. The final horizon is not the edge of space or the end of time. It is the boundary of everything you thought you knew about the nature of existence itself. And beyond that horizon, infinite new horizons await your exploration. The cosmos is calling you to wonder, to question, to investigate, to explore. The universe needs conscious observers who are willing to confront mystery without demanding easy answers, who can live with uncertainty while continuing to probe deeper into the unknown. You are the universe investigating itself. The questions you ask are cosmic questions. The wonder you feel is cosmic wonder. The mystery you explore is the mystery of existence itself. And somewhere out there, beyond the final horizon, in dimensions of space and time we cannot even imagine, the story continues. Other forms of consciousness are asking other questions, exploring other mysteries, pushing against other boundaries of the known. The cosmic conversation extends infinitely in all directions, and your voice is part of that infinite dialogue. The universe may have no end, but maybe, just maybe, neither do you. But maybe, just maybe, neither do you.